In this tutorial, I'm going to show you how to download and install Python on your computer. So the first thing I want you to do is open up your browser and head over to python.org. On this page, click on Downloads. Here you can see the latest version of Python. Currently, at the time of recording this video, the latest version is Python 3.7.2. Chances are in the future, when you're watching this tutorial, there is a newer version of Python available. Don't worry, all the materials you're going to learn in this course will apply to the latest version of Python as well. So let's go ahead and download Python 3. All right, now look at your downloads folder. Here we should have Python 3 installer. Simply double click that. If you're on Windows, you're going to see this checkbox here, add Python to path. This is really important. Make sure to tick this box. Otherwise, you're not going to be able to follow this tutorial. If you're on a Mac, you're going to see an installer like this. With this setup wizard, we can install Python 3 on our computer. So simply click continue and again. Agree with the license agreement and install it. This is going to take a few seconds, so I'm going to pause the recording. All right, we have successfully installed Python 3 on our computer. Let's close this. All right, next we need to install a code editor. We use a code editor to write our code. Just like how we use Microsoft Word to write documents, we use a code editor to write code. Now, there's so many code editors out there. The one that I'm going to show you in this tutorial is PyCharm. That is one of the most popular code editors for writing Python code. You can get it from jetbrains.com/PyCharm. Now, more accurately, PyCharm is considered an IDE, which is short for Integrated Development Environment. And that's basically a code editor on steroids. It has some additional features that makes it really easy to write code. So let's go ahead and download PyCharm. Now here on the download page, you can see two versions of PyCharm. One is the professional edition, which has additional features and you'll have to pay for them. The other is the community edition. That is absolutely free, and that's what we're going to use in this tutorial. So go ahead and download this as well. Now, once again, look at your downloads folder. Here you should have PyCharm. So double click this. Now, if you're on Windows, you're going to see an installation wizard. Simply click next until you install PyCharm. If you're on Mac, you need to drag and drop this icon onto the applications folder. So drag and drop. All right, now let's double click this to run it. The first time you run PyCharm, you're going to get this warning because this is an application that you download from the internet. So let's go ahead and open it. Next, you're going to see this dialog box for importing some settings. Leave this to do not import settings. It doesn't really matter. Okay. On this page, select I've never used PyCharm. You can see some keyword shortcuts that might be useful in the future. Just accept this. And down the bottom, click the next button. And then next again. And one more time. And finally start using PyCharm. So here's the main page of PyCharm that you're going to see every time you open it. Click on Create New Project. This is the location for our project. Let's call this project Hello World. Now, before clicking Create, expand this item here. Make sure that base interpreter is set to Python 3. Python interpreter is basically a program that knows how to execute Python code. It will interpret or translate Python instructions into instructions that a computer can understand. Now, Mac computers by default come with an older installation of Python, that is Python 2. It's considered legacy, which means it's no longer maintained or supported. So earlier we downloaded Python 3. Make sure that this is set to Python 3. If not, from this list, select Python 3.7. All right, now let's go ahead and create this project. Now here, right-click on Hello World folder and go to New Python file. Call this file app.py. So by convention, all Python files should have this Py extension. All right, let's go ahead. Now let's collapse this project panel by clicking here and write our first Python program. Simply type print, P-R-I-N-T, all in lowercase, open and close parentheses, and inside this parentheses, add quotations. You can either use single quotes or double quotes. Now, in between the quotes, write your name. I am Mosh Hamadani, so let's write that here. So this is your first Python program. With this piece of code, you can print your name on the screen. Now to run this, go on the top, under the Run menu, click Run. Also note that there is a shortcut associated with this command. When I program, I always use shortcuts because that increases my productivity. So here on a Mac computer, the shortcut is Control, Option, and R. On Windows, it's different. So let's go ahead with that. Now it's asking where you want to run this. Click on App. Now down below, you should see this little terminal window. This is like a little window into our program. So here we can see the results or output of our program. In the future, as you learn more Python, you'll be able to build applications that have a graphical user interface or GUI. That is a little bit complicated. So for now, we're going to use this little terminal window to see the results of our program. So as you can see, my name is printed here. Now, as you write code, this window might get in the way, so you can always resize it or minimize it by clicking this icon here. So this was our first Python program. Now, if you didn't see the result I showed you in this video, use the comment box below and tell me what error you encountered. I'll do my best to help you move forward. In this Python tutorial, we're going to take this program to the next level. We're going to make it more interesting. So I'm going to show you how to draw a dog here. Now, as part of this tutorial, you will learn how Python code gets executed, and you will also learn about a few programming terms. So press enter, and on line 2, write another print statement. So print, open and close parentheses, add a quotation. Now here we want to draw a dog. So I don't know, that is the head of our dog, followed by 4 hyphens. 1, 2, 3, 4. So this is the body. All right. Now one more time, another print statement with quotations. Now we need to draw the legs. So add a space, followed by 4 vertical bars. So like this. So here's a little imaginary dog. Now let's run this program and see what we get. So on the top right corner, you should see this play button. Click that. There you go. So we have our name, and right below that, we have our imaginary dog. Now what you need to understand here is that our Python code gets executed line by line from the top. So earlier I told you about Python interpreter. That is the program that knows how to translate or interpret our Python code into instructions that a computer can understand. So when we run this program by clicking this icon here, Python interpreter starts executing or running our program line by line from the top. So first it executes line 1, then moves on to line 2, and so on. So this is how Python programs get executed. Now let me show you something cool. Let's add another print statement with quotations. Now in between the quotations, add a star or an asterisk like this. Now after the quotation and before the parenthesis, add a space. Once again, add an asterisk, space, 10. What is going on here? Well, anywhere we have quotations, like here or here, we're defining a string. A string is a programming term, which means a series of characters. So here we have a string. We also have a string on line 3, as well as line 2 and line 1. Now here, we are multiplying this string by number 10. So this is the multiplication operator, just like the multiplication operator we have in math. So with this piece of code, we can draw 10 asterisks on the terminal. Let me show you. So let's run this program one more time. There you go. So we have 10 asterisks. Now what we have here, this piece of code here, is called an expression. An expression is a piece of code that produces a value. So when Python interpreter tries to execute line 4, first it will evaluate the code that we put in between parentheses. So it will evaluate our expression. Our expression will produce 10 asterisks, and then those asterisks will be printed on the terminal. Now, as an exercise, you can use these print statements to draw another shape. You can draw a heart, a ball, whatever you like. I will see you in the next tutorial. One of the questions I get a lot on my channel is, how long does it take to learn Python and become job ready? Well, there is no single answer. It really depends on you and how much effort and commitment you want to put into this. But I would say if you spend 2 hours every day consistently, after about 3 months, you should be able to write basic Python programs. But quite honestly, that doesn't get you a job. In order to get a job, you need to specialize in one area. What do you want to use Python for? Do you want to use it to build web applications or desktop applications, or do you want to use it in machine learning and artificial intelligence? So whatever you want to do, you need to take additional courses. For example, if you want to become a web developer, in addition to learning Python, you should also learn about HTML, CSS, some JavaScript, and Django, which is a popular Python framework for building web applications. Learning all these things would take you another 6 months. So in total, you need 9 to 12 months to become job ready. At that point, you can get a junior developer job with a salary of about $50,000 to $60,000 a year. Now, as you work more, as you do more Python projects, your resume starts to build, and you can ask for $100,000 a year or $120,000 a year, depending on where you are, what company, what geographical area. It really depends. So there is no single answer. So are you excited to learn Python and get started on this career path? If you are, I would encourage you to make a commitment and spend 2 hours every day practicing Python. And use the comment box below and let me know why you're learning Python. What do you want to do with it? What's your dream job? I would love to hear your story. In this Python tutorial, you're going to learn about variables, which are one of the most fundamental concepts in programming. They're not specific to Python. They exist in pretty much every programming language out there. We use variables to temporarily store data in a computer's memory. Here's an example. Let's type price equals 10. When Python interpreter executes this code, it will allocate some memory, then it will store the number 10 in that memory, and finally it will attach this price label to that memory location. As a metaphor, imagine we have a box. In that box, we have number 10, and price is the label that we put on the box. Now we can use this label anywhere in our program to access the value that we have in that box. This is a very simplified explanation. So now let's print price on the terminal. Print. Now this time we're not going to add quotations, because if we put quotations here, we will see the text price on the terminal, not the value of the price variable. So delete quotations and type price. Now let's run this program one more time. There you go. So we see 10 on the terminal. So this is how we define variables. We start with an identifier, which is the name of our variable, then an equal sign, and finally a value. Now, more accurately, when this number 10 is about to be stored in the memory, first it will get converted to its binary representation. So this number 10 that we have is in the decimal system, which has all the digits from 0 to 9. Computers don't understand all these digits. They only understand zeros and ones. So when we store the number 10 in the computer's memory, first it will get converted to its binary representation, which will be a bunch of zeros and ones, like 001001, whatever, I don't know. Then it will get stored in the computer's memory. So let's take this program to the next level. On the second line, we can update the value of this price variable. So we can reset it to a new value like 20. Now, when we run our program, we should see 20, because as I told you before, Python interpreter executes our code line by line from the top. So first we set price to 10, then we reset it to 20, and finally we print it on the terminal. Let's run the program. There you go. So we see 20 here. Okay. Now these numbers that we have here are whole numbers without a decimal point. In programming, we refer to these numbers as integers. So an integer is a number without a decimal point. We can also use numbers with a decimal point. For example, here on line 2, we can define another variable called rating, and we set it to 4.9. Now in programming, we refer to this kind of number as a floating point number, or float for short. So we have integers and floats. We can also define a variable and set it to a string. For example, name equals Mosh. We also have another kind of value, which is called Boolean, which can be true or false. They are like yes and no in English. Here's an example. I'm going to define a variable is underline published. So we use an underscore to separate multiple words in our variable's name. We set this to true or false. These are the Boolean values. Now, note that Python is a case-sensitive language, which means it's sensitive to lowercase and uppercase characters. So when defining variables, we should always use lowercase letters. But here, false and true are special keywords in the language. So if we spell it with a lowercase f, Python doesn't understand it. You can see we have a red underline here, which indicates an error. So make sure to spell this with a capital F, or if you want to set this to true, make sure T is capital. So in this program, we are storing simple values in our computer's memory. Simple values can be numbers, which can be integers or floats, or they can be strings or booleans. But in Python, we can also store complex values like lists and objects, and that's what I'm going to show you in the future. So before going any further, I want you to do a little exercise. Imagine we're going to write a program for a hospital. So we check in a patient named John Smith. He's 20 years old and is a new patient. I want you to define 3 variables here for his name, his age, and another variable to tell if this is a new or an existing patient. So pause the video and spend 1 minute on this exercise. When you're done, come back, continue, see my solution. All right, so here we need 3 variables. The first one is the patient's name. We set that to John Smith. We can also call this full name. These are both valid names for our variables. The second variable is for the age of our patient. So age is 20. And finally, we need a variable to tell if this is a new or an existing patient. That's where we can use a Boolean value. So we define a variable is new and we set it to true. So you have learned how to print messages on the terminal window. In this tutorial, I'm going to show you how to receive input from the user. So we're going to write a small program that asks the user's name, and then it will print a greeting message customized for that user. So instead of print, we're going to use input. Now, both this input and print are functions that are built into Python. As a metaphor, think of the remote control of your TV. On this remote control, we have a bunch of buttons. These are the functions built into your TV. You can turn it on, turn it off, change the volume, and so on. In Python, we also have a bunch of functions for common tasks, such as printing messages, receiving input, and so on. So we're going to use the input function. Now, whenever we have these parentheses, we say we're calling or executing that function. It's like pressing a button on a remote control. So we're going to call the input function, and in between parentheses, we want to add a string to print something on the terminal. What is your name? With a question mark followed by a space. You'll see why in a second. So this input function will print this message on the terminal, and then it will wait for the user to enter a value. Whatever the user enters, this input function will return. So now we can get that value and store it in the memory using a variable. So we get the result and put it in a variable called name. Okay? Now on the second line, we want to print a message like hi John or hi Mosh, whatever. So print quotations, hi with a space. Now after the quotation, we want to dynamically print what we have in the name variable. So we add a plus sign and then name. So here we have hi, which is a string. We're concatenating or combining this string with another string. That is what we have in the name variable. So here's another example of an expression. Remember what is an expression? It's a piece of code that produces a value. So this expression concatenates or combines two strings. Let's run this program and see what happens. So run. Okay, here's the question. What is your name? Mosh. Now note that earlier we added a space after the question mark. We did this so here in the terminal window, the cursor is separated from the question mark. Otherwise, it would be so close. So let's type whatever here, press enter. Now we get this message, hi Mosh. Now here's a little exercise for you. I want you to extend this program and ask two questions. First, ask the person's name and then their favorite color, and then print a message like Mosh likes blue. So pause the video, do this exercise, and then come back, continue watching. All right, so here's the first question. Right after that, we're going to call the input function one more time. This time we're going to ask a different question. What is your favorite color? Now we get the new value and store it in a variable called color, or we could call it favorite underline color. Either works. And finally, we're going to change what we pass to the print function. So first we print the name, then we concatenate this with a string. Here we're going to type likes. We also put one space before and after likes. And once again, we concatenate this with the favorite color. So favorite color. Now let's run this program. So what is your name? Mosh, enter. Favorite color, blue, enter. We get this message, Mosh likes blue. Hey guys, Mosh here. I just wanted to let you know that you really don't have to memorize anything in this course because I've put together a cheat sheet with summary notes so you can quickly review the materials in this course. The link is below this video. So I have done my best to create the best possible Python course on YouTube. And I really appreciate it if you support my hard work by liking this video and sharing it with others so they can learn as well. And be sure to subscribe to my channel for more tutorials like this. All right, now let's move on to the next tutorial. In this Python tutorial, we're going to write a program that will ask the year we were born in, and then it will calculate our age and print it on the terminal. So let's start with our input function, input. Let's print birth year, followed by a colon and a space. Now let's get the return value and store it in a variable called birth underline year. So as I told you before, we use an underscore to separate multiple words. Next, we need to calculate the age. So we define another variable called age, and here we do some basic math. Currently we are in 2019. So let's write an expression like this. 2019 minus birth year. Now finally, let's print age on a terminal. Let's run our program and see what happens. So my birth year is 1982. Enter. Oops, we got an error. What is going on here? So whenever you see this red message, that means there is something wrong in your program. With the information here, we can find exactly where the error occurred. So next to the file, you can see the file that generated this error. In this case, that is app.py. So currently our program has only a single file, but real complex programs often have hundreds or even thousands of files. So in this file, on line 2, this is where we got this error. And right below that, you can see the piece of code that generated this error. So that is where we're calculating the age. And right below that, you can see the type of the error. In this case, we have a type error, and here's the message: unsupported operand types for subtraction, int and stir. So int is short for integer, and that represents a whole number, and stir is short for string. So here we're subtracting a string from an integer, and Python doesn't know what to do with it. Let me explain. So I'm going to close the terminal window. So after the first line is executed, we have this birth year variable set to a string. So whatever we type in the terminal is always treated as a string, even if we type a number. In other words, when we run this program, this birth year variable will be set to a string with 4 characters, 1982. This string is different from the actual number 1982. One is an integer, the other is a string, right? So back to line 2, where this error occurred. At runtime, which means when we run our program, this expression on the right side of the assignment operator is going to look like this: 2019 minus string 1982. Python doesn't know how to interpret or how to evaluate this expression. To fix this problem, we need to convert this 1982 into an integer, and then we'll be able to subtract it from 2019. And that is very easy. So far, you have learned about 2 built-in functions. One is print, the other is input. We have a few more functions for converting values into different types. So we have int for converting a string into an integer. We also have float for converting a string into a float or a number with a decimal point. And we also have bool for converting a string into a Boolean value. So to fix this problem, we need to go back on line 2 and pass this birth year variable to the int function like this. Int parentheses like this. So we pass this string to the int function. Int will convert it to an integer, and then Python interpreter will be able to evaluate this expression. Now let's run this program one more time. So birth year is 1982, enter. So I am 37 years old. In Python, we have a useful function for getting the type of variables. For example, let's print the type of birth year. So right after line 1, let's print. Now here we're going to call another built-in function called type. And now let's pass birth year. Okay. Now similarly, after line 3, let's also print the type of age. So print type of age. Okay. Let's run our program. So birth year, one more time, 1982. Okay. Here's the result. So the type of birth year, as you can see, is a class of stir or string. We'll look at classes in the future. So for now, don't worry about them. And also below that, you can see that the type of the age variable is int or integer. So here's what you need to take away. Whenever you use the input function, you always get a string. So if you're expecting a numerical value, you should always convert that string into either an integer or a float. Now here's a little exercise for you. I want you to write a program, ask the user their weight, and then convert it to kilograms and print it on the terminal. So pause the video, do the exercise, and when you're ready, come back, continue watching. All right, so let's use our input function and ask for the weight in pounds. Here we get the weight in lbs or pounds. Now we need to convert this into kilogram. That is very easy. So we define another variable, weight underline kilogram or kg. We set this to weight underline lbs times 0.45. And finally, let's print weight underline kilogram. Let's run this Python program and see what happens. So my weight is 160. All right, once again, we got an error. Can't multiply sequence by non-int of type float. So as I told you before, this input function returns a string. So we cannot multiply a string by a float. Python doesn't know what to do with it. So in this case, we should convert this number to an integer or a float and then multiply it by 0.45. So let's call the int function and pass weight underline LBS and run our program one more time. 160. Okay, so I am 72 kilograms. In this tutorial, you're going to learn more about Python strings. So I've defined this course variable and set it to Python for beginners. Now, earlier I told you that you can use both single and double quotes to define a string. But there are times that you have to use a specific form, otherwise you're going to run into issues. Here's an example. Imagine we want to change this string into Python's course for beginners. So we want to add an apostrophe like this, Python's course for beginners. You can immediately see this is going crazy because our string starts here and then terminates here. All these characters that we have after the second apostrophe, Python interpreter doesn't know what they are. So to solve this problem, we need to use double quotes to define our string so we can have a single quote in the middle of the string. So let's change this to double quotes. Now you can see it adds another double quote to close it. We have to manually remove this. And also one more time at the beginning of the string, we need to add another double quote. Now you can see the error is gone. So if we print course, we see Python's course for beginners. Beautiful. Now let's say we don't want this apostrophe here. So we have Python for beginners, but we want to put beginners in double quotes. Once again, if we add a double quote here, Python interpreter gets confused because it assumes the second double quote indicates the end of our string, so it doesn't know what these characters are. So to solve this, we need to change our double quotes to single quotes like this, and then we can add double quotes in the middle of the string. Now let's run this program. There you go. So we get Python for beginners. So these are the cases for using single or double quotes. Now, in all the examples I've shown you so far, we only deal with short strings. But what if you want to define a string that is multiple lines? For example, what if you want to define a string for the message that we send in an email? In that case, we need to use triple quotes. So let me delete this. Now we add 3 quotes. So 1, 2, 3. There you go. So we have 3 quotes to start our string and 3 to terminate it. Again, these quotes can be single or double quotes. Okay. Now with this, we can define a string that spans multiple lines. For example, we can say, "Hi, John. Here is our first email to you. Thank you, the support team." Like that. Now, let's run this program and here's the result. So we get this beautiful multi-line string. Now let's change this back to something simple so we can look at other characteristics of strings in Python. So I'm going to use single quotes and set the course name to Python for beginners. Now here we can use square brackets to get a character at a given index in this string. Let me show you. So to get the first character, we use square brackets and type 0. So the index of the first character in this string is 0. In other words, this is how Python strings are indexed. 0, 1, 2, 3, 4, and so on. So the index of the first character is 0. The second character is 1, and so on. So let me delete this and run this program. We get P. We can also use a negative index here. And this is one of the features that we don't have in other programming languages, as far as I know. So with a negative index, we can get the characters starting from the end. So if I pass -1 here, assuming that 0 is the index of the first character, -1 is the index of the last character. So when we run this program, we should see S. Let's run it. There you go. We get S. If we pass -2, this will return the second character from the end. Let's run it one more time. Now we get R because that is the second character from the end. Okay. So pay close attention to this square bracket syntax because quite often it's the topic for online Python tests or university exams. So if you're preparing for a Python test, make sure to watch this tutorial one more time and understand exactly how this square bracket syntax works. We can also use a similar syntax to extract a few characters instead of just one character. For example, if we type 0:3, Python interpreter will return all the characters starting from this index all the way to this second index, but it does not return the character at this index. In other words, back to these indexes. So we have 0, 1, 2, 3, and so on. When we run this program, Python interpreter will return the characters starting from index 0 all the way to index 3, but excludes the character at index 3. So when we run this Python program, we're going to see PYT. Let me show you. So I'm going to delete this line, run this program. There you go. We get PYT. Now here we also have default values for the start and end index. So if we don't supply the end index, Python will return all the characters to the end of the string. Let's take a look. So run this program. There you go. We get Python for beginners. But if we change the start index to 1, this will exclude the first character. So when we run this program, we see YTHON. So P is removed. Okay. Now, similarly, we have a default value for the start index. So if we don't supply the start index, but add an end index like 5, Python interpreter will assume 0 as the start index. So let's run this program. There you go. We get PYTHO. Now, what if we leave both the start and end index? Well, I told you that in this case, 0 will be assumed as the start index, and the length of the string will be assumed as the end index. So with this syntax, we can basically copy or clone a string. In other words, if I define another variable here, let's call it another, and set it to course square brackets with just a colon, now this expression will return all the characters in the course variable. So this second variable will be a copy of our first variable. Let's take a look. So let's print another and run our program. There you go. We get Python for beginners. So once again, the square bracket syntax is pretty important. If you're preparing for online Python tests or college exams, make sure to watch this tutorial again. Now here's a little exercise for you. I'm going to delete all this code, define a variable called name, and set it to Jennifer. Now, when we print name of 1:-1, what do you think we're going to see on the terminal? I want you to use your knowledge to tell what we're going to see on the terminal without running this program. So pause the video, think about it for a few seconds, and then come back, continue watching. So this expression will return the characters starting from index 1, which is the second character, all the way to the first character from the end, but excluding the character at this index. In this case, the first character from the end is R, so R will be excluded. In other words, we're going to see all the characters starting from E all the way to this second E. Let's take a look. So I'm going to run this program. There you go. This is what we get. And I hope you guessed it right. In this tutorial, we're going to look at formatted strings in Python programming language. Formatted strings are particularly useful in situations where you want to dynamically generate some text with your variables. Let me show you. Let's say we have two variables, first name and last name. So first, we set this to John, and last, we set this to Smith. Now, it's better to call these variables first name and last name because they're more descriptive. But here I'm using shorter names because I want you to see the entire code on the screen. So let's say with these two variables, we want to generate some text like this. John, in square brackets, Smith is a coder. Let's say we want to print this on the terminal. How do we do this? Well, we define another variable like message. Now here we add the first name. Now we need to concatenate this with a string that contains a space and a square bracket. Next, we need to add the last name. Then we need to add a string that contains the closing square bracket followed by is a coder. Okay, so then if we print message and run this program, we see John Smith is a coder, right? Now, while this approach perfectly works, it's not ideal because as our text gets more complicated, it becomes harder to visualize the output. So someone else reading this code, they have to visualize all these string concatenations in their head. This is where we use formatted strings. They make it easier for us to visualize the output. So I'm going to define another variable, let's say MSG, short for message, and set this to a formatted string. A formatted string is one that is prefixed with an F. So F quotes. Now in between the quotes, first we want to add the value of the first name variable. So we add curly braces, and here we type first. Next, we add a space. We add our square brackets. In between the square brackets, we want to display the last name. So once again, we add curly braces and type last. And finally, here we type is a coder. So this is what we call a formatted string. With these curly braces, we're defining placeholders or holes in our string. And when we run our program, these holes will be filled with the value of our variables. So here we have two placeholders or two holes in our string. One is for the value of our first name variable, and the other is for the value of the last name variable. Now compare this formatted string with string concatenation. With this formatted string, we can easily visualize what the output looks like, right? Now let's print this on the terminal to make sure we get the exact same output. So let's print message. There you go. So John Smith is a coder. So to define formatted strings, prefix your strings with an F and use curly braces to dynamically insert values into your strings. In this Python tutorial, I'm going to show you some really cool things you can do with Python strings. So let's start by defining a variable, course, and we set that to Python for beginners. Now to calculate the number of characters in this string, we can use a built-in function called len. So len, we give it this course variable, and then we can print the result. Let's run this program. So as you can see, we have 20 characters in this string. This is particularly useful when we receive input from the user. For example, you have noticed that when you fill out a form online, each input field quite often has a limit. For example, you might have 50 characters for your name. So using this len function, we can enforce a limit on the number of characters in an input field. If the user types in more characters than we allow them, we can display an error, okay? Now, this len function is another function built into Python. It's a general purpose function. So it's not limited to counting the number of characters in a string. In the future, when we look at lists, I'm going to show you that we can use this function to count the number of items in a list. So it's a general purpose function. Now, we also have functions specific to strings. For example, we have functions for converting all these characters to uppercase or lowercase. To access these functions, we use the dot operator. Let me show you. So First we type course, then dot. Look, these are all the functions that are specific to strings. Now, in more accurate terms, we refer to these functions as methods. This is a term in object-oriented programming that we'll look at in the future. But for now, what I want you to take away is that when a function belongs to something else or is specific to some kind of object, we refer to that function as a method. For example, here we have this function, upper, for converting the string into uppercase. Now, more accurately, because this function is specific to strings, we refer to this as a method. In contrast, len and print are general purpose functions. They don't belong to strings or numbers or other kinds of objects. Okay? So this is the difference between functions and methods. Now, let's look at this upper method. So let's print the result and run our program. There you go. We get all these characters displayed in uppercase. Now note that this method does not change or modify our original string. In fact, it creates a new string and returns it. So if we print our course variable right after we call the upper method, you can see that our course variable still has its original form. So let's run this program one more time. There you go. Look, this is our original course variable. It's not modified. Now, similar to the upper method, we have another method for converting a string into lowercase. So let me show you. Print course dot lower. Now let's run the program. So on the second line, you can see all characters are in lowercase. Now there are times that you want to find a character or a sequence of character in a string. In those situations, you can use the find method. So let me delete these few lines. We call course dot find. Here we pass a character, let's say P, and this will return the index of the first occurrence of that character. Let me show you. So let's print the result. We get 0 because the index of the first capital P in our string is 0. As another example, if we pass a lowercase o here, let's see what we get. We get 4 because the index of this o here is 4. Now, note that the find method is case sensitive, so it's sensitive to lowercase and uppercase characters. As an example, if we pass an uppercase o here and run this program, we get -1 because we don't have an uppercase o anywhere in this string. Okay, we can also pass a sequence of characters. For example, we can pass beginners with a capital B. Let's run this program. We get 11 because the word beginners starts at index 11. Now, we also have a method for replacing a character or a sequence of characters, and that is called replace. So let's change find to replace. Let's say we want to replace beginners with absolute beginners. So we add a comma to pass a second value to this function, or more accurately, this method. We add a string. Here I'm going to pass absolute beginners. Okay, now let's run this program. So we get Python for absolute beginners. Again, this method, like the find method, is case sensitive. So if we pass beginners all in lowercase, this method is not going to find this exact word in our string, so it's not going to replace it with absolute beginners. Let's take a look. So I'm going to run the program one more time. Look, we still get Python for beginners. We can also replace a single character. For example, we can replace capital P with, let's say, capital J. Now, when we run this program, we get Python for beginners. So these are the find and replace method. And one last thing I want to show you in this tutorial. There are times that you want to check the existence of a character or a sequence of characters in your string. In those situations, you use the in operator. So let's say we want to know if this string contains the word Python. We can write an expression like this. String Python space in space course. So we're checking to see if Python is in the course variable. Now, this is an expression that produces a Boolean value, like a true or false. So we refer to this expression as a Boolean expression. Now, if we print this on the terminal, we should get true. And by the way, let me delete the second line. We don't need it anymore. So run the program, we get true. But if I change this capital P to a lowercase p and run the program, we get false because we don't have this exact sequence of characters in our string. Now note that the difference between the in operator and the find method is that our find method returns the index of that character or sequence of characters. But the in operator produces a Boolean value. Do we have this or not? So that's the difference. Now let's quickly recap all the cool things you learned to do with strings in this tutorial. We can use the len function to count the number of characters in a string. This is a general purpose function built into Python. We also have specific functions for strings, which we refer to as methods. These include upper for converting a string into uppercase. We also have lower and title methods. You learn about the find method, which returns the index of a character or sequence of characters. We have the replace method for replacing characters and words in a string. And finally, you learn about the in operator. So some characters in a string. So you have learned that in Python programming language, we have two types of numbers. Integers, which are whole numbers like 10, they don't have a decimal point. And floating point numbers or floats, which are numbers with a decimal point. Now, in this tutorial, we're going to look at the arithmetic operations supported in Python language. These are the same arithmetic operations that we have in math. We can add numbers, multiply them, and so on. So let's look at a few examples. We can print 10 plus 3. So this is the addition operator. We also have subtraction. We have multiplication. We have two kinds of division. Here's one with a forward slash. Let's run this program and see what we get. We get a floating point number. But we also have another division operator for getting an integer. So if we add another slash here and run this program, we get an integer. We have another operator called modulus, which is a percent sign, and this returns the remainder of the division. So when we run this program, we should get 1. There you go. And one last operator we have here is exponent, which is the power. So that is indicated with 2 asterisks, and this will return 10 to the power of 3. So let's run this program, we get 1,000. So these are the arithmetic operators in Python programming language. Now for all these operators that you learned, we have an augmented assignment operator. That is very useful. Let me show you. So let's say we have a variable called x. We set it to 10. Now we want to increment this by 3. We'll have to write code like this. X, we set this to x plus 3. So Python interpreter will add 10 to 3. The result is 13, and then it gets stored into x again. So when we print x, we should see 13. There you go. So this is how we can increment a number, right? Now, augmented assignment operator is a way to write the same code, but in a shorter form. This is how it works. We type x plus equals 3. What we have on line 3 is exactly like what we have on line 2. So this is what we call the augmented assignment operator. We have augmented or enhanced the assignment operator. Now in this particular case, we are incrementing a number using the augmented assignment operator, but we can also subtract or multiply a number by a given value. For example, let's delete what we have on line 2. We can type subtract equal 3. So here we are subtracting 3 from x. When we run this program, we should see 7. There you go. Now let me ask you a question. I'm going to clear all this code here. Define x and set it to 10 plus 3 times 2. What do you think is the result of this expression? This is a very basic math question that unfortunately a lot of people fail to answer. The answer is 16. Because in math we have this concept called operator precedence, which means the order of operations. So the multiplication operator has a higher precedence, so it's applied first, which means 3 by 2 is executed first, the result is 6, and then it's added to 10. That is why x should be 16 after we run this code. Let's verify that. So print x, run the program, x is 16. So this is what we call operator precedence. It's just a basic math concept. It's not about Python programming language. So all the other programming languages behave the same way. So here's the order. First we have the exponentiation, which is the power, like 2 to the power of 3. Then we have multiplication or division. And finally we have addition or subtraction. This is the order of operations. Let me show you another example. Here I'm going to add the exponentiation operator. So 2 to the power of 2. Once again, what do you think is the result of this expression? Pause the video and think about it for a few seconds. The answer is 22. Because the exponentiation operator takes precedence, so first 2 to the power of 2 is executed, the result is 4. Then 4 is multiplied by 3, that is 12. And finally 12 is added to 10. So x should be 22. So let's run this program and verify this. So I'm going to delete these lines here, run the program. There you go. X is 22. Now let me bring back these rules here. We can also use parentheses to change the order of operations. So if we have parentheses, it always takes priority. In this case, we can add parentheses around 10 plus 3. So this piece of code will be executed first. The result is 13. Then the exponentiation operator will be executed. So 2 to the power of 2 is 4. And finally 4 is multiplied by 13. Now here's a little exercise for you. I'm going to set x to parentheses 2 plus 3 times 10 minus 3. What is the result of this? Pause the video and think about it for a few seconds. So you learned that parentheses always overrides the order. So this piece of code is executed first. The result is 5. Then between the multiplication and subtraction, you know that multiplication takes precedence. So next, 5 will be multiplied by 10. The result is 50. And finally, we have the subtraction. So 50 minus 3 will be 47. Let's verify this. Print x, run the program. There you go. I hope you guessed it right. So this is all about operator precedence. It's a very important topic, and I see it quite often in Python tests. So if you're preparing for a Python test, make sure to watch this tutorial one more time. In this tutorial, we're going to look at a few useful functions for working with numbers. Let's start by defining a variable like x and set it to 2.9. Now to round this number, we can use the built-in round function. So we call the round function, give it x, and then print the result. Let's run this program. So we get 3. We have another useful built-in function called ABS, which is short for absolute. And this is the absolute function that we have in math. We give it a value and it always returns the positive representation of that value, even if that value is negative. Here's an example. Let's call the ABS function and give it negative 2.9. When we run this program, we're going to see 2.9 on the terminal. So let's go ahead. There you go. So absolute always returns a positive number. Now, technically in Python, we have a handful of built-in functions for performing mathematical operations. If you want to write a program that involves complex mathematical calculations, you need to import the math module. A module in Python is a separate file with some reusable code. We use these modules to organize our code into different files. As a metaphor, think of a supermarket. When you go to a supermarket, you see different sections for fruits and vegetables, cleaning products, junk food, and so on. Each section in a supermarket is like a module in Python. So in Python, we have this math module, which contains a bunch of reusable functions for performing mathematical calculations. So let me show you how to use this module. On the top, we type import math, all in lowercase. With this, we can import the math module. Now math is an object like a string, so we can access its functions, or more accurately, its methods, using the dot operator. So if we type math dot, look, these are all the mathematical functions available in this module. For example, we can call the ceil method to get the ceiling of a number. So if we pass 2.9 here and then print the result, we should see 3. Let me delete all this other code here. All right, let's run this program. There you go. So we get 3. Another useful method is the floor method. So let's give that a try. Floor of 2.9. What do you think we're going to get? We get 2. Now, there's so many functions built in this module, and we don't really have time to go through all of them. But let me show you how you can learn about them on your own. Open up your browser and search for Python 3 math module. Make sure to add the version Python 3, because the math module in Python 2 is slightly different from the math module in Python 3. So Python 3 math module. Now here you can see the documentation for this module. Let's go. Let's have a look. If you scroll down, you can see the list of all the functions and their explanation. So as an exercise, I encourage you to spend 5 minutes, have a quick look at this documentation, see what functions are there for you in case you need them. In this tutorial, I'm going to talk to you guys about if statements in Python. If statements are extremely important in programming, and they allow us to build programs that can make decisions based on some conditions. So if some condition is true, we're going to do certain things. Otherwise, we're going to do other things. Here's an example. Over here, I've got this text file with a bunch of rules for our program. If it's a hot day, perhaps we want to tell the user it's a hot day, so make sure to drink plenty of water. Otherwise, if it's cold, so here's another condition. If this condition is true, we're going to tell the user it's a cold day, so wear warm clothes. And otherwise, if it's neither hot or cold, we want to tell the user it's a lovely day. So let me show you how to write a program that simulates these rules. So back to our program here, we start by defining a Boolean variable is underline hot. We set this to true. Next, we add an if statement. So if, here we need to add a condition. In this case, we're going to use our Boolean variable. So is underline hot. Now, if this if value is to true, then we're going to do certain things. In this case, we want to tell the user, hey, it's a hot day, drink plenty of water. So back to our program. After our condition, we add a colon. Now, note that when I press enter, PyCharm automatically indents our cursor. Now, any code that we write here will be executed if this condition is true. Otherwise, it will be ignored. Here's an example. Let's write a print statement. Here I'm going to use double quotes because I want to use an apostrophe in our string. So it's a hot day. Now let's press enter. You can see the cursor is still indented. That means we can write more code that will be executed if this condition is true. In this case, let's say we don't want to write any extra code. So to terminate this block, we need to press Shift and Tab. Now the cursor is at the beginning of the line. So let's write a print statement with a message like, enjoy your day. Now, when we run this program, because this condition is true, we're going to see this message followed by this second message. Take a look. So run. There you go. It's a hot day. Enjoy your day. But if I go over here and change this Boolean value to false and run the program again, our first message disappears and we only see the second message, enjoy your day. So this is how if statements work. Now back here, we can add another print statement. Let's say, drink plenty of water. Now, because this print statement is also indented, it will be executed if this condition is true. So I'm going to revert is hot to true and run the program one more time. There you go. So it's a hot day, drink plenty of water, and enjoy your day. All right, now let's add a second rule here. If it's hot, we're going to execute these two lines. Otherwise, if it's not hot, we want to print a different message. So here, we remove the indentation and type else colon. Now, when we press enter, once again, our cursor is indented. So the code that we write here will be executed if this condition is not true. So here we can print, it's a cold day, print, wear warm clothes. Now let's run our program one more time. So we get the messages about a hot day followed by enjoy your day. We don't see any messages about a cold day. Now, if we go back here on the top and change this Boolean value to false and run our program, we see different set of messages. It's a cold day, wear warm clothes, and enjoy your day. But there's a problem with our program. If it's not hot, it doesn't necessarily mean that it's cold. Maybe it's a lovely day. So the absence of heat doesn't mean it's cold. Back to our conditions. Here on line 4, we have this rule that says, if it's a cold day, then print these messages. Otherwise, if it's neither hot or cold, then say it's a lovely day. So to implement this rule, we need to go back to app.py and define another variable. So let's say is underline cold. We set this to true. Now here we need to add a second condition. So after our first if statement, we can use an elif statement to define a second condition. Here's how it works. So elif, which is short for else if or otherwise if. Now here we add another condition. So is cold. So if it's cold, we want to execute these two lines. So let's cut these from here and move them under our second condition. And finally, if none of these conditions are true, you want to print a different message. It's a lovely day. So right now, is hot is false, is cold is true. So when we run this program, Python interpreter is going to execute the first if statement. In this case, because our condition is false, these two lines will be ignored. Then Python interpreter will look at line 7. It will evaluate this condition. In this case, is cold is true. So we're going to see these two messages on the terminal. Now, in this case, because one of these conditions was true, this else statement will be ignored. So we are not going to see this message. And finally, as before, we're always going to see this message. So let's run our program. There you go. It's a cold day. Wear warm clothes and enjoy your day. Now, back to the top. If we change is cold to false, it's neither hot nor cold. So it's going to be a lovely day. Let's run the program. And here you go. It's a lovely day. Enjoy your day. So this is the basic of using if statements. As you can see, they're very useful in programming. And with these, we can build all kinds of rules into our programs. Okay, here's an exercise for you. Imagine the price of a house is $1 million. Now, if the buyer has good credit, they need to put down 10% of the price of this property. Otherwise, they need to put down 20%. Write a program with these rules and display the down payment required for a buyer with good credit. You will see my solution next. All right, let's define a variable for the price of this house. So price, we set this to 1 million. So 1 with 6 zeros. Next, we need a variable to tell if this buyer has good credit. So has good credit. And we set this to true. Now we need an if statement. So if has good credit is true, colon. Here we need to calculate the down payment. So down underline payment should be equal to 0.1 times the price. That is 10% of the price of this property. Otherwise, colon, the down payment should be 0.2 times price. Now finally, we remove the indentation and print. Here we can use a formatted string. First, we add a label, down payment, colon, and right after that, we add a placeholder or a hole for our down payment variable. So curly braces, down payment. Let's run this program. So down payment for a buyer with good credit is $100,000. Now let's improve this by adding a $sign before this number. So back to our formatted string, just before the curly brace, I'm going to add a $sign. Let's run this one more time. That is better. In this tutorial, I'm going to talk to you guys about the logical operators in Python. We use these operators in situations where we have multiple conditions. Here's an example. Let's say we're building an application for processing loans. If an applicant has high income and good credit, then they're eligible for loan. So in this example, we have two conditions. One is having high income and the other is having good credit. So if both these conditions are true, then the applicant is eligible for loan. So this is where we use the logical AND operator. We use this operator to combine two conditions. And by the way, this is not specific to Python programming language. Pretty much any programming language that supports if statements also supports the logical operators. So back to our program, let's define two variables. Has high income, we set this to true. And another one has good credit. We also set this to true. Now our if statement. If has high income is true and has good credit is also true, then we're going to print eligible for loan. So this is where we're using the AND operator. So if both these conditions are true, then this message will be printed. If one of them is false, we're not going to see this message. Let's try this out. So I'm going to run this program. So we see eligible for loan. But if we change either of these conditions to false and run the program again, look, the message disappeared. So this is the logical AND operator. We also have the logical OR, and we use that in situations where we want to do certain things if at least one of the conditions is true. For example, let's change the rule for this program such that if the applicant has high income or good credit, then they're eligible for loan. So if either or both these conditions are true, then the applicant is eligible. Now, back to our program, we can implement this rule by using the logical OR operator. So we simply replace AND with OR. Now, when we run this program, we're going to see this message because at least one of our conditions is true. Let's take a look. So the applicant is eligible for loan because they have good credit. If we change this to false, but set the other condition to true and run the program, we still see the same result. But if both these conditions are false, then we're not going to see this message anymore. So this is the difference between these operators. With the logical AND operator, both conditions should be true. With the logical OR operator, at least one condition should be true. We also have another logical operator called NOT, and that basically inverses any Boolean value we give it. If we give it a true Boolean value, it converts it to false. For example, let's make up a new rule. If applicant has good credit and doesn't have a criminal record, then they're eligible for a loan. Let me show you how to implement this. So we go back to our program. In this example, we don't need the first variable, so let's delete that. Let's set this variable to true. We also define another variable like has criminal record. And we set this to false. Now we want to check to see if this applicant has good credit and not a criminal record. This is where we use the not operator. So if they have good credit and not criminal record. So in this example, has criminal record is set to false. When we use the not operator, this basically gets changed to true. So we'll have two conditions that are true. Here's one and here's another one. So our applicant is eligible for loan. And when we run this program, we see this familiar message. However, if an applicant has criminal record, so let's change this to true. Now, when we run this program, we can see our applicant is not eligible because when we apply the not operator on this variable, we'll get false. So true changes to false. And we'll end up with two conditions. One is true and the other is false. So the result is false. And that's why this message is not printed. So this is all about the logical operators in Python. In this tutorial, I'm going to talk to you guys about the comparison operators in Python. We use comparison operators in situations where we want to compare a variable with a value. For example, if temperature is greater than 30, then we want to print it's a hot day. Otherwise, if it's less than 10, it's a cold day. Otherwise, it's neither hot nor cold. And by the way, here I'm talking about Celsius, not Fahrenheit. So to build these rules into our program, we need to use comparison operators. Back to app.py. I'll define this temperature variable. Let's write an if statement. If temperature, now we want to check to see if this is greater than 30. So we use the greater than operator. If this is greater than 30, we want to print it's a hot day. Otherwise, let's just print it's not a hot day. Now, when we run this program, we're going to see the second message because 30 is not greater than 30. So our first condition evaluates to false. Let's verify that. So run, it's not a hot day. Okay. Now, if we change the temperature to 35 and run this again, we're going to see a different message. It's a hot day. So this is where we use comparison operators. Now, what we have here, as you know, is an expression because it's a piece of code that produces a value. So more accurately, this is a Boolean expression. So this is the greater than operator. We also have greater than or equal to. We have less than or equal to. Here's the equality operator. So if the temperature equals to 30, then we can say it's a hot day. Note that this is different from the assignment operator that has only one equal sign. You can see if we use one equal sign here, we immediately get this red underline because this is simply an assignment statement. We're changing the value of the temperature. We're setting the value of the temperature variable to 30. We are not comparing it with something else. So we don't have a Boolean expression. We are not producing a Boolean value. Okay? So our equality operator has two equal signs And finally, we have not equal, which is an exclamation followed by an equal sign. Now, here's an exercise for you. You've probably seen that when you fill out a form online, sometimes the input fields have validation messages. For example, let's say we have an input field for the user to enter their name. Now, if the name is less than 3 characters long, we want to display a validation error like name must be at least 3 characters. Otherwise, if the name is more than 50 characters long, then we want to display a different validation error like name can be a maximum of 50 characters. Otherwise, if the name is between 3 and 50 characters, then we just want to tell the user that name looks good. So go ahead and write a program to implement these rules. All right, let's define a variable called name and set it to, let's say, J. So we're assuming this is what the user types into an input field. Now we want to get the number of characters in this string. So we use the len function, right? Len of name. When we print this, we get 1, right? You have seen this before. Now here we want to use an if statement. So if len of name is less than 3, then we want to print name must be at least 3 characters. Now here we need a second condition to check the upper limit. So L if len of name is greater than 50, then we want to print a different message. Name must be a maximum of 50 characters. Okay, and otherwise, so else, if none of these conditions is true, that means the name looks good. So print name looks good. Let's run our program. So in this case, we get this message because our name is too short. Now, if you go back here and type something really, really long, and then run our program, we're going to see a different message. Name must be a maximum of 50 characters. And finally, if we type a proper name here, like John Smith, and run our program, we get name looks good. Here's another good exercise that combines many of the materials you have learned so far. So earlier you built a program to convert someone's weight from pounds to kilograms. Now we want to extend this program and allow the user to enter their weight in either kilograms or pounds, and then we'll convert it to the other unit. Here's how our program is going to work. So I enter my weight in pounds, so 160. Now it's telling me, is this in pounds or kilograms? So here I need to enter L for pounds or K for kilograms. And by the way, this program is not case sensitive. So whether I enter a capital L or a lowercase l, it takes it as pounds. Now it tells me you are 72 kilos. Let's run this program one more time. This time I'm going to enter my weight in kilos. So 72 is the weight and the unit is kilograms, so K. And it says you are 160 pounds. So go ahead and spend a few minutes on this exercise. You will see my solution next. All right, first, let's ask the user their weight. So we use the input function, weight colon. We get the return value and store it in a variable called weight. Now the second question. So one more time, we use the input function, L for pounds, LPS, or K for kilograms. So let's get that too and store it in a variable called unit. Now we need an if statement. So if unit equals L, then we need to convert this weight into kilograms. However, with this implementation, we are only allowing the user to enter a capital L. If they enter a lowercase l, this code is not going to work. So this is where we use the upper method of string objects. So this unit is a string because, as I told you before, the input function always returns a string. So we can use the dot operator to access all its methods or functions. Here we call the upper method. This will convert whatever the user enters to uppercase, and then we'll compare it with a capital L. Now, if this condition is true, then we need to get the weight and multiply it by 0.45. However, as you know, this weight is a string object, and we cannot multiply a string by a floating point number. We talked about this earlier in this course. So first we need to convert this weight to a numerical value. So right here, when we call the input function, we can get the return value and pass it to the int function. So we call the int function and give it the return value of the input function. Now the int function will return an integer, so we can store it in this weight variable. So here's the converted weight. Let's store it in a variable called converted. Then we print. Here we can use a formatted string. So we prefix the string with F. We add curly braces to dynamically insert the value of converted variable. And finally, we add kilos. Otherwise, if the unit is kilogram, we need to divide the weight by 0.45. So once again, we type converted equals to weight divided by 0.45. And just to refresh our memory, this division operator returns a floating point number, but if we use double slashes, we'll get an integer. In this case, I want to get a floating point number. So finally, let's print a formatted string, curly braces, converted pounds. Okay. Now let's run this program and see what happens. So weight is 160 in pounds, and that equals to 72 kilos. Perfect. If we run it one more time and enter 72 kilos, we get 160 pounds. In this tutorial, I'm going to show you how to use while loops in Python. We use while loops to execute a block of code multiple times, and they're often useful in building interactive programs and games. In a future tutorial, I'm going to show you how to build a simple game using a while loop. So let's get started with the basics. We write a while statement, and right after that, we type a condition followed by a colon. As long as this condition is true, the code that we write in this block will be repeatedly executed. Here's an example. We can define a variable like I, as in short for index, and set it to 1. Now, we set our condition to I less than or equal to 5. So as long as I is less than or equal to 5, we can print I on the terminal. And then we need to increment I by 1. So we set I to I plus 1. The reason we do this is that if we don't do this, I will be 1 forever. So we'll end up with an infinite loop because this condition will always be true. 1 is always less than 5. So in every iteration of this loop, we increment I by 1. So at some point, I is going to be 6. And then that is when this condition will be false. And then we'll jump out of this loop. Okay. Now to demonstrate how everything works, after this loop, I'm going to add a print statement, say done. So note that these two lines are indented, so they're part of the while block. Okay. Now let's go ahead and run this program to see what happens. So take a look. We get the numbers 1 to 5 followed by done. So here's how this program gets executed. First, we set I to 1. Now Python interpreter executes line 2. This condition is true because I is less than 5. So I is printed on the terminal and then incremented by 1. Then the control moves back to the beginning of the while loop. So it doesn't go to the next statement. So we come back here. Now we are in the second iteration. In the second iteration, I is 2. And because 2 is less than 5, our condition is still true. So I will be printed on the terminal. And once again, it will be incremented by 1. So at some point, I is going to be 6. And that's when this condition will be false. So our loop will be terminated. And then this done message will be printed on the terminal. So this is the basics of while loops. Now let's make this program a little bit more interesting. Here we can write an expression like this. We add a string, and in this string we add an asterisk. And then we multiply this string by I. So with this expression, we can repeat a string. When we multiply a string by a number, that string will be repeated. For example, if I is 2, this expression will produce a string with 2 asterisks. Okay, now let's run the program and see what we get. So we get this little triangle shape here, because in the first iteration, I is 1. So 1 times an asterisk produces 1 asterisk. In the second iteration, I is 2. So when we multiply 2 by 1 asterisk, we'll get 2 asterisks. In this tutorial, I'm going to show you how to use a while loop to build a guessing game like this. So we have this secret number, which is currently set to 9. Now the computer is asking me to make a guess. So let's say 1. It's not right because the secret number is 9. I can try again. 2. No, it's not right. Let's try again. So I only have 3 chances to make a guess. If I can't guess the number, the program tells me that I failed. Let's run the program one more time. This time I'm going to guess the number. So it's 9. There you go. It says you win. So let's go ahead and build this program using a while loop. All right, let's start by defining a variable to store our secret number. So we call that secret underline number and set it to 9. Now we need a while loop to repeatedly ask a user to make a guess. So while condition colon. What is our condition here? Well, we want to give our user a maximum of 3 guesses. So similar to the last tutorial, we can define a variable like I, set it to 0, and assume this represents the number of guesses the user has made. And then we can write our condition as I less than 3. Note that here I'm not using less than or equal to operator because with this condition, our loop will be executed 4 times while I is 0, 1, 2, and 3. So here we should use the less than operator. Now, if we give this code to someone else, it's not quite clear what does I represent here. It's only in our head that I represents the number of guesses the user has made. So as a best practice, always use meaningful and descriptive names for your variables. So it's better to rename this variable to guess count. Let me show you how to rename. So right click on I variable and then go to refactor and rename. Look at the shortcut. On a Mac computer, that's Shift and F6. Now in this dialog box, we can easily rename a variable and PyCharm will update all the references to that variable. So we don't have to manually update each instance, okay? Let's change this to guess underline count. Enter. There you go. Now that is better. Also, it's better to store 3 in a separate variable to make our code more readable because it's not quite clear what does 3 represent here. So let's define a variable called guess limit and set it to 3. And then we can change 3 to guess underline limit. Now our code is more readable. While guess count is less than guess limit, see, it reads like a story. This is how you should write code. All right. So while this condition is true, we want to ask the user to make a guess. So here we use our input function, guess. Now, whatever the user enters comes out as a string, so we need to convert it to an integer. So right here, we pass the result to the int function, and then get it and store it in a separate variable called guess. So at this point, the user made a guess. Now we need to increment guess count. So guess count, we set it to plus equal 1. Okay. Now we need to check to see if the user made the right guess. So here we need an if statement. If what the user guessed equals our secret number. Again, see, our code is so readable. It's like a story. You can read it like plain English. So if this condition is true, we want to tell the user they won. So print you won. Now let's go ahead and run our program up to this point. So, okay, it's asking me to make a guess. I'm going to make the wrong guess. So 1, it asked me again, beautiful. 2, one more time, 3. Okay, what is missing in this implementation is the message that tells me that I failed. We're going to take care of it momentarily. But let's run the program one more time and make the right guess. So 9, okay, it says you won, but it's still asking me to make a guess because our while loop is going to get executed 3 times. Look, 1 and 2. So we need to change our program such that if the user makes the right guess, we need to terminate our while loop. We need to jump out of it. How do we do that? So over here, if the user makes the right guess, after we print this message, we can use the break statement to terminate a loop. When Python interpreter sees this, it's going to immediately terminate our loop. It's not going to evaluate this condition again. Now let's run our program and see what happens. So I'm going to guess the right number. You won, and look, we were not asked to make 2 more guesses. Beautiful. Now the last thing that we need to add here is the message that tells the user that they failed if they couldn't guess the right number. How do we do that? Well, in Python, our while loops can optionally have an else part, similar to the if statements. So earlier you learned that our if statements can optionally have an else part, like here. So if this condition is true, do this, otherwise do something else, right? In this case, our if statement doesn't have an else part. Now, similar to the if statements, our while loops, our while statements can also have an else part. So right at this level, we can add an else block, so else colon, and the code that we write here will get executed if this while loop completes successfully without an immediate break. In other words, if the user guesses the right number, we break this loop, we jump out of it, so the code that we write in the else block will not get executed. But if the user cannot guess this number, we're never going to break out of this loop, so this loop will be executed to completion until this condition becomes false. In that case, the code that we write in the else block will get executed. And this is the perfect opportunity for us to tell the user, hey, you made 3 guesses, but none of them were right. So print, sorry, you failed. Now let's test our program one more time. So guess 1, 2, 3. Sorry, you failed. Let's run it one more time. This time I'm going to make a wrong guess and then the right guess. We won, and our loop terminated immediately. All right, now it's time for you to practice what you have learned so far. So once again, we're going to build a game. This game is a simulation for a car game. Now, our game doesn't have a graphical user interface or GUI, and it doesn't really matter for now. Our focus is entirely on building the engine for this game. So let's see how this program works. When we run this, we get this little symbol here, and our program is waiting for us to enter a command. If we type help, either in lowercase or uppercase, it doesn't matter. We get the list of commands that our program or our game currently supports. So we can type the start command to start our car. We can type the stop command to stop our car, and quit to terminate the game. any other commands that we type, our program is going to tell us, hey, I don't understand that. For example, if I type ASD here, it says, I don't understand that. If we type start, we get this message, car started, ready to go. If we type stop, it says car stopped. And finally, if we type quit, our program terminates. This is a fantastic exercise for you to practice what you have learned. So pause the video and spend 5 to 10 minutes to build this program. All right, we're going to start with a while loop with a condition. What is our condition here? We want to run this loop until the user types quit. So we can define a variable for storing the command that the user enters, and then we can run this loop as long as the command does not equal to quit. So right before the loop, we define a variable command, and initially we set it to an empty string. An empty string is a string that has no characters in it. We only have the quotes, okay? So then we type out our condition as while command does not equal to quit, then do something. Now immediately we have a problem here because we're assuming that the user types the command in lowercase. So if they type this in uppercase, our program is not going to behave properly. So to fix this problem, we need to call the lower method of the string object and then compare the result with this quit. We could also call upper and then type quit in uppercase. It's a matter of personal preference. In this demo, I'm going to use lowercase characters. So, okay. Now in this loop, we need to ask the user to enter a command. So once again, we're going to use our input function. We add a greater than symbol followed by a space. Whatever the user enters, we get it and store it in our command variable. Now, apart from the quit command, there are 3 other commands that we need to support: start, stop, and help. So here we need an if statement to compare what the user enters with one of the supported commands. So if command that lower equals start, then we want to print a message like the car started. So print car started, ready to go. It doesn't matter. Now the second condition. What if it's not start? Maybe it's stop. So elif command that lower equals stop. There you go. Then we print a different message, car stopped. Now look at our code. We have repeated this lower, lower, lower multiple times. This is bad. In programming, we have a term called dry, which is short for don't repeat yourself. So whenever you have duplicate in your code, that means you're doing something wrong. So how can we solve this problem? Well, instead of calling the lower method in each condition, we can call it right here when we get the input from the user. So this input function, as you know, returns a string. We can immediately call the lower method on that string, and with this, our command will always be in lowercase. So we don't need to call this method in every condition. Look, we remove the duplication, and also our conditions are shorter and easier to read. There's also one more place we need to modify, so it's right here. That is better. Now the third command. We need one more elif. If the command equals help, then we want to show the commands that we support. So here we're going to print a multi-line string. So we use triple quotes like this and give the user a guideline like this. So start, to start the car, stop, to stop the car, and quit, to quit. Now finally, we need an else part. So if what the user enters is none of these commands, we're going to tell them, hey, we don't understand this. So else colon print, sorry, I don't understand that. And by the way, Note that here, because I'm using double quotes, I can easily use a single quote as an apostrophe. Okay, so let's run our program up to this point and see what happens. All right, let's type start, car started, beautiful, stop, car stopped, help. We get this guideline, but there's so much indentation before our commands. We'll fix that in a second. And finally, let's test the quit command. Oops, our program didn't work properly. Here's the reason. With these if statements, we're comparing the command with start, stop, and help. Anything else will end up here. So that's why our program says it doesn't understand that. So that's why our program says it doesn't understand that command. However, after this else statement, the control will be moved to the beginning of the loop. At this point, our command is quit, so our loop will complete and the program terminates. In other words, when we run this program and type quit, our program actually quits, but we still see this message, which shouldn't appear here. How can we solve this problem? Well, we can come back here and just before the else block, add another elif, something like this. Elif command equals quit. Then we can immediately break. This will solve our problem, but note that we have kind of repeated this expression in two places. The reality is we don't really need this condition on the top because with these if statements, well, more accurately, with this elif, we can jump out of this loop and terminate our program. So we can simplify our condition to something like this. True. So while true means this block of code is going to get executed repeatedly until we explicitly break out of it. Okay. Now let's test our program one more time. So quit. Now our program terminates and we don't see that message. Beautiful. So let's fix the last problem. You saw that when we typed help, these guidelines appeared with so much indentation. And here's the reason. Look, right here in our code, they're already indented. So when we use triple quotes, what we type here will be printed exactly as is. So because we have indentation here, this indentation will also be printed on the terminal. So let's delete these. Okay, run the program one more time. Type help. The indentation is gone. Beautiful. Now here's a challenge for you. I want you to take this program to the next level. So right now, if we type start, we get this message, car started. And if we type start again, we get the same message. It would be better if we got a message like car is already started. So it doesn't make sense to start a car twice. Similarly, if we type stop, it says car stopped. If we type it again, we get the exact same message. It doesn't make sense to stop a car twice. So here's what I need you to do. If the car is stopped and the user tries to stop it again, the program should say, hey, the car is already stopped. What are you doing? And similarly, if the car is already started and the user tries to start it again, the program should yell at the user. So go ahead and make the necessary changes to implement this scenario. All right, to add this to our program, we need to know if the car is started or not. So there is one more piece of information that we need to store in the memory. What is the kind of data we need to store here? A Boolean. Is the car started or not? It's a matter of yes or no, true or false. So on the top, here we can define another variable like started, and initially we set it to false. So the car is not started, right? Now, when the user types the start command, here we need to check to see if the car is already started. If not, we'll start it, otherwise we'll yell at the user. So in this block, we write another if statement. If it's already started, then we print car is already started. Otherwise, so we add an else statement here. And at this point, we set started to true. So we start the car and print this message. Okay. Now we need to make a similar change for the stop command. So if the car is already stopped, we need to print a different message. If not started, so here we're using the not operator to see if the car is stopped. So if it's not started, that means it's stopped. Okay. So if it's stopped, we print car is already stopped with double P's. Otherwise, so else, we need to stop the car. How do we do that? We set started to false. And then we'll print this message. As easy as that. Let's go ahead and run our program. So initially our car is stopped. So I'm going to type stop. It says the car is already stopped. So let's start it. Okay, now our car is started. Let's start it one more time. The program is yelling at us. So we cannot start the car twice. Beautiful. Now let's stop it. It says the car is stopped. Let's stop it one more time. We get this message again. In this tutorial, I'm going to talk to you guys about for loops in Python. In the last tutorial, you learned about while loops. You learned that we use while loops to execute a block of code multiple times. In Python, we have another kind of loop that is a for loop, and we use that to iterate over items of a collection, such as a string, because a string is a sequence of characters. So it looks like a collection. So we can use a for loop to iterate over each character in a string and then do something with it. Here's an example. We type out for, then we define a variable. This is what we call a loop variable. In each iteration, this variable will hold one item. So let's call it item. In here we type out a string like Python and then colon. So with this for loop, we can iterate over this string, and in each iteration, this item variable will hold one character at a time. In the first iteration, it will be set to P. Then in the second iteration, it will be set to Y. In the third iteration, it will be set to T, and so on. Okay. So here we are inside our for block because of the indentation here. So whatever we type here will be executed in each iteration. For now, we can simply print this item. Now, let's run this program and see what happens. So you can see each character in our string is printed on a new line. Let's look at another example. In Python, we can define lists using square brackets. So let me remove this string from here and define a list using square brackets. A list is simply a list of items, like a list of numbers, a list of customers, a list of emails, products, blog posts, whatever. So here we can define a list of names like Mosh, John, Sarah, and then go ahead, run our program. So you can see in each iteration, we get one name and print it on a new line. We can also loop over a list of numbers. For example, 1, 2, 3, 4. Let's run it. Again, we see each number on a new line. But what if we want to iterate over a large list of numbers? We don't want to explicitly type out a list with, let's say, 100 or 1,000 numbers. We don't want to type 5, 6, 7, all the way to 100. That is when we use the range function. So let me delete this. In Python, we have a built-in function called range for creating a range of numbers. So we give it a number, let's say 10. Let's run this program. Now we can see here on the terminal, we have numbers 0 all the way to 9. So 10 is not included. So basically, when we call the range function, this range function creates an object. It's not a list, it's a special kind of object that we can iterate over. In each iteration, this object will spit out a new number. We can also work with a range of numbers here. Let's say we want to start from 5 and go all the way to 10. So let's run our program. Now we have the numbers 5, 6, 7, and 9. Also, this range function can optionally take a step. So we can pass 2 as the step to this function. And when we run our program, you can see that our first number is 5. Now we go 2 steps forward to get 7. Once again, we go 2 steps forward, we get 9, and that is the end of our range. So this is the basics of using for loops in Python. Now here's an exercise for you. I want you to write a program to calculate the total cost of all the items in a shopping cart. So let's say we have a list of prices like 10, 20, and 30. I want you to use a for loop to calculate the total cost of all the items in our imaginary shopping cart. So calculate that and then print it on a terminal. That's pretty easy, and you should do it in a couple of minutes. So as you learned, we use for loops to iterate over all the items in a collection. A collection can be a string, it can be a list, it can be a range object that is returned from the range function, anything, any kind of object that has multiple items. So in this example, we're going to use a for loop to iterate over the list of prices. So for item in prices, colon, and by the way, this loop variable, we don't have to call this item, we can call it anything. For example, in this case, we can rename it to price. So for price in prices. Now in each iteration, this price will hold one value. In the first iteration, it's going to hold 10, then it's going to be 20, and then it's going to be 30. So we need to define another variable to calculate the total. So we define that outside of our for loop. Let's call it total, and initially we set it to 0. Now in each iteration, we get the current price and add it to the total. So we write total equals total plus price, or as you learned earlier, we can use the augmented assignment operator to simplify this code. So after our for loop, this total variable has the total of all the prices. We can simply print it here, or we can use a formatted string. So a string prefixed with F. We add a label like total, curly braces, to dynamically include some value in our string. In this case, our total variable. So let's go ahead and run this program. There you go. So the total cost of all the items in our imaginary shopping cart is 60. In this tutorial, I'm going to talk to you guys about nested loops in Python. Using a nested loop basically means adding one loop inside of another loop. And with this technique, we can do some amazing things. For example, we can easily generate a list of coordinates. So a coordinate, as you know, is a combination of an X and Y value. Let's say 0 and 0. Now let's say we want to generate a list of coordinates like this. So we have 0 and 0, then we'll have 0 and 1, then 0 and 2. Next, we're going to change X, so we're going to use 1 for the X. And once again, we're going to use these 3 values for the Y coordinates. So 1 and 0, then 1 and 1, and 1 and 2. You got the point. We can easily generate these coordinates using nested loops. Let me show you. So we'll start with one loop. Let's say for X in range 4. With this loop, we can generate values for the X coordinate. Let's print this on the terminal. Okay, so we get the values 0 to 3. Now, for each X, like 0, we should generate a few Y values. So that is where we use a nested loop. So inside of this loop, we're going to add another loop. So instead of just printing X, first we want to add another loop for Y in range, let's say 3. Now we can print X and Y together. So print, here we use a formatted string to display coordinates like this. So we add parentheses. Inside of this parenthesis, first we need to add X, so curly braces, X. then a comma, followed by another set of curly braces, and y. Let's run this program and see what we get. There you go. So we have these coordinates 0 and 0, 0 and 1, 0 and 2. Then we have 1 and 0, 1 and 1, 1 and 2, and so on. So let me explain exactly how this program gets executed. So in the first iteration of our outer loop, x is 0, right? Now we are on line 2. Here we have a new loop, which we call an inner loop. In this inner loop, in the first iteration, y is going to be 0. So we'll print 0 and 0 on the terminal. Now the control goes back to line 2, or our inner loop. In this second iteration, y will be set to 1, but we're still in the first iteration of our outer loop. So x is still 0, but now y is incremented to 1. So that is why we see 0 and 1 on the terminal. Once again, the control goes back to line 2. We are in the third iteration of our inner loop. So this will continue until this inner loop completes. That is when y reaches 2, because this range function generates number 0 to 3, but not including 3. So we'll have 0, 1, and 2. After this inner loop completes, then the control goes back to line 1. At this point, we're going to be in the second iteration of our outer loop. So x will be 1. Then the control will be moved to line 2, or our inner loop. At this point, this range function is going to generate the numbers 0 to 3 one more time. So this inner loop will be executed 3 times, and then we'll go back to our outer loop. So this is how nested loops get executed. Okay, here's an exercise for you, but this one is a little bit more challenging than the exercises we have done so far. So I really don't expect you to do it, but if you do it, wow, I will be so proud of you. So see what I have done here? Using nested loops, I've written some code to draw this F shape. Can you see that? So let me give you a hint. First of all, we have this list called numbers. In this list, we have these values, 5, 2, 5, 2, 2. These values determine the number of x's we have on each line. So, for example, the first item in this list, this tells us that we should have 5 x's on the first line. There you go. So 1, 2, 3, 4, 5. On the second line, we're going to have 2 x's. On the third line, we're going to have 5 x's, like this. So I've written code to convert a simple list of numbers into a shape like this. Now here's a tip for you. Using a for loop, you need to iterate over this list. In each iteration, you get one number. This determines the number of x's to be displayed on that particular line. So if you want to cheat, you can get this number and multiply it by a string that contains x. So if you multiply x by 5, you'll get 5x's. That's not what I want you to do. I want you to use an inner loop here to generate a string that contains 5x's. So imagine in Python, we cannot multiply a string by a number. So to solve this problem, we need a nested loop. So go ahead and spend 5 minutes on this exercise. And by the way, do your best to solve this. It is a little bit challenging, but it's not extremely difficult. It just requires a little bit of focus. You'll see my solution next. All right, so first we need to iterate over all the items in this list. So for item in numbers, or we could rename this variable to x underline count. That is the number of x's on each line, okay? Now I told you that if you want to cheat, you can write code like this. Print x times x underline count. If we run this program, we get the same output. So this is the beauty of Python. With Python, we can write expressions like this. We can multiply a string by a number to repeat it. A lot of other programming languages don't support this feature. But for this exercise, I wanted you to imagine that we don't have this feature in Python, so you would have to use an inner loop to solve this problem. Here's how it works. In the first iteration, x count is going to be 5. So we need to generate 5 x's. How can we do that? Well, let's say we define a variable called output, and initially we set it to an empty string. Now we need to add 5 x's to this string. So we can use another loop for count in range of x underline count. So we're using the range function to generate a sequence of numbers from 0 up to x count. So in our first iteration, x count is going to be 5. So range of 5 would generate the numbers 0, 1, 2, 3, 4. So this inner loop will be executed 5 times. That is exactly what x count represents. So now, in each iteration, we simply need to append an x to our output variable. So we said output plus equals x. And then after this inner loop, we simply print the output. With this, we'll print 5 x's on the first row. Then we go to the second iteration of our outer loop. At this point, x count is going to be 2. Now, on line 3, we're going to reset our output variable to an empty string. So we start over. Then we go to our inner loop. This loop will be executed 2 times. So we'll append 2 x's to the output variable and then print it. As simple as that. So see, it wasn't really that difficult, but it was slightly more difficult than the previous exercises. So let's run this program. There you go. Now, if you're adventurous, I want you to modify the values that we have in our numbers list to print an L here. Now, in this tutorial, we're going to take a closer look at lists. So I'm going to define a list of names. Let's set them to John, Bob, Mosh, Sarah, and Mary. So if we print this list here, what we see on the terminal looks exactly like how we define our list. So we have square brackets, and in between these square brackets, we have our items. So we have 5 strings in this list. Now we can also access an individual element using an index, just like how we can access an individual character in a string using an index. So here we type out square brackets and specify an index. The index of the first item in this list is 0. So let's run this program. There you go. We get John. Now if you want to print out the third element in this list, its index is 2. So names of 2 returns Mosh. Now we can also pass a negative index here. So -1 refers to the last item in this list, that is Mary. Let's run the program. There you go. We see Mary. If we pass -2, this returns the second item from the end of the list. So let's run the program. There you go. We get Sarah. So this is exactly like accessing individual characters in a string. We can also use a colon to select a range of items. For example, if we pass 2 colon, this will get all the items starting from the index of 2, that is Mosh here, all the way to the end of the string. So let's run this program. There you go. We get this list with 3 items, Mosh, Sarah, and Mary. We can also specify an end index, let's say 4. So this will return all the items up to this index, but it doesn't include the item at this index. So when we run this program, we only see Mosh and Sarah. The item at index 4, which is the 5th element or the 5th item in this list, is not returned. So Mary is not returned. Okay. And also here we have default values. So if we leave out the end index, this expression is going to return all the items starting from the index of 2 to the end of the list. Or if you leave out the start index, this expression assumes 0 as the default index. So it will return all the items from the beginning to the end of the list. Okay. And by the way, just like strings, these square brackets here don't modify our original list. They simply return a new list. For example, if we pass 2 here, you can see this returns a new list with 3 items. So if we go back here and print our original list of names right after, you can see it's not affected. So whenever we use square brackets with a colon to select a range of items, we get a new list. And by the way, we can also modify any of the elements in this list. For example, let's say we made a mistake and the first item shouldn't be spelled John with an H. So we want to remove the H. That is very easy. So we access it using an index that is names of 0, and we set it to a new value like this. Now let's print our list. So you can see the first item in this list is now updated. So this is the basics of lists. And here's an exercise for you. I want you to write a program to find the largest number in a list. This is a fantastic exercise for beginners. So go ahead and spend a few minutes on this and then come back, continue watching. All right, let's define a list of numbers with a bunch of random numbers, 3, 6, 2, 8, 4, and 10. Now, to find the largest number in this list, we need to define another variable. Let's call it max. This variable will hold the largest number. Now, initially, we want to assume that the first item in this list is the largest number. So we set max to numbers of 0. We're only assuming that the first item is the largest number. Chances are our assumption is wrong. So we need to iterate over this list. We need to loop through it, get each item, and compare it with max. If it's greater than max, then we need to reset max to that number. So in the first iteration, we get 3, and max is also 3. Is 3 greater than 3? No, so we move on. We get the second number. Is 6 greater than 3? It is. So we need to reset max to 6. Once again, we continue. We get 2. Is 2 greater than 6? No, it's not. So we move on. Then we get 8. Is 8 greater than 6? It is. So we should reset max to 8. That is pretty easy. So here we need a for loop. For number in numbers, colon. Now we need to check to see if this number is greater than max. So if number is greater than max, colon, then we need to reset max. So we set max to this new number. That's all we had to do. So let's print max and run our program. We can see the largest number in this list is 10. It doesn't matter whether this number is at the end of the list or at the beginning. So if I move 10 and put it right at the beginning, we should still see the same result. Let's run our program. We still see 10. If I put this somewhere in the middle, our program should still work. Let's put it right after 2. Run the program. We still get 10. In this tutorial, I'm going to talk to you guys about two-dimensional lists in Python. Two-dimensional lists are extremely powerful, and they have a lot of applications in data science and machine learning. Here's an example. In math, we have a concept called matrix, which is like a rectangular array of numbers. Let me show you. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a rectangular array of numbers. We have rows and columns. So this is a 3 by 3 matrix in math. Now we can model this in Python using a two-dimensional list. A two-dimensional list is a list where each item in that list is another list. So you want to define a matrix. We set it to a list. Each item in this list is going to be another list, and that list represents the items in each row. So the first item in our list is going to be another list, and in this list we're going to have the values 1, 2, and 3. Now the second item in our matrix list. Once again, we have a list. This list represents the items in the second row. So 4, 5, and 6, and finally 7, 8, 9. So as you can see, we have a two-dimensional list. Each item in our outer list is another list. Okay, so this is how we can implement a matrix in Python. Now, to access an individual item in our matrix, once again, we use square brackets. Let me delete this stuff. All right. So how do we access one here? Well, we start with our list. Then we add square brackets. First, we need to go and get the first item in this list, right? So we pass 0. Now, this expression returns another list. That is the inner list. In this list, let's say we want to access the second item. So once again, we add square brackets and we pass 1. That is the index of 2 in this list, right? So if we print this on the terminal, we get 2. Okay, so using 2 square brackets, we can access individual items in our matrix. And also we can modify these values using this syntax. So before printing this, let's change it to 20. So matrix of 0 and 1, let's change it to 20 and then print it. There you go. It's modified. Now here we can also use nested loops to iterate over all the items in this matrix. Let me show you. So we start with a rows for row in matrix. So with this loop, we are iterating over our matrix list. In each iteration, row will contain one list, one item, okay? Now, here we need to use an inner loop. So we need to loop over this row, which is a list of items. We can type out for item in row, colon, and print item. Okay, so let's run this program. There you go. We get all the items in our list. Hey, I just wanted to make a quick announcement. In case you haven't seen my website yet, head over to codewithmosh.com. This is my coding school where you can find plenty of courses on web and mobile application development. In fact, recently I published a comprehensive Python course that goes way beyond this beginner's course on YouTube. And if you're serious about learning Python and getting a job, I highly encourage you to enroll in this course. Just like this tutorial, you can watch it anytime, anywhere, as many times as you want. And you will also receive a certificate of completion that you can add to your resume. And the course comes with a 30-day money-back guarantee. So if you're not happy, we give all your money back. No questions asked. The price for this course is $149, but the first 200 students can get it for only $15. So if you're interested, the link is below this video. Click the link and get started. In this tutorial, I'm going to talk to you guys about the list methods or list functions. These are the operations that we can perform on a list. So let's define a list of numbers. Here we pass a bunch of random numbers like 5, 2, 1, 7, and 4. Now, there are a number of things we can do with this list. We can add new items to it. We can remove existing items. We can check for the existence of an item. These are the operations that we can perform on a list. So when we type numbers dot, we can see all these functions, or more accurately, the methods that are available in our list objects. So we can call the append method to add a new item to this list. Let's say 13. Actually, no, it's not a good number. I'm joking. I'm not superstitious. So let's add 20. It doesn't really matter. And then print our list. When we run the program, you can see 20 is added at the end of this list. But what if you want to add a number somewhere in the middle or at the beginning of our list? For that, we use a different method that is called insert. So insert. Now this method takes two values. Let me show you. So when we open parentheses, look at this little tooltip above the insert method. You see the first value that we need to pass here is an index. So this is the index at which we want to insert this new item. Let's say we want to add an item at the beginning of our list. So we pass the index position of 0, and then the second value is the actual object we want to add to this list. Let's say we want to add the number 10. Now, when we print this list, you can see that the number 10 is placed at the beginning of the list, and all the other items are pushed to the right. We can also remove an item, so we call remove and pass the item that we want to remove. Let's say we want to remove 5. Now we print our list, so you can see 5 is gone, and we have 2174. If you want to remove all the items in the list, you can call the clear method. So clear. This method doesn't take any values, so we simply call it and it empties our list. All the items are removed. We also have another useful method called pop. And with this, we can remove the last item in a list. Let me show you. So run our program. You can see the number 4 is removed from the end of our list. Now, if you want to check for the existence of an item in a list, you can call the index method. So we call index and pass a value here like 5, and this returns the index of the first occurrence of this item. So let's print this on the terminal. We don't need this line anymore. So the index of 5 is 0. What if we pass a number that doesn't exist in this list? Let's say 50. Run the program. We get an error. We get a value error. 50 is not in the list. There is also another way to check for the existence of an item. We can use the in operator. So let me show you. We type out 50 in numbers. Earlier, we used the in operator with a string. We could check for the existence of a character or a sequence of characters in a string. Now here we're checking for the existence of 50 in the list of numbers. So let's print this. We get a Boolean value, false. So unlike the index method, this expression doesn't generate an error. So it's safer to use this. We also have another method for counting the occurrences of an item. Let's say we have another 5 over here. Now we can call numbers that count and pass 5, and this should return 2 because we have 2 5s in this list. Take a look. There you go. That is pretty useful. Now if you want to sort your lists, you can call the sort method. So we call the sort method here. This method doesn't take any values, so look at the return value. That is none. None is an object in Python that represents the absence of a value. So this sort method doesn't really return any values. It simply sorts this list in place. So instead of printing the return value of this method, we simply call it to sort our list and then print our list. Take a look. Now all the items are sorted in ascending order. We can also sort the items in descending order. So after we sort the list, we can call the reverse method, and this simply reverses our list. Now let's go ahead and run our program. Take a look. Our numbers are sorted in descending order. And one last method I want to show you here that is pretty useful is the copy method. So copy. With this method, we can get a copy of our list. So let's define another variable called numbers2. Now numbers2 is a copy of our original list. So if you make any changes to our original list, if you add new items to it, if you remove existing items, these operations are not going to impact our second list. Let me show you. So after we take a copy of our numbers list, let's add a new item to this list. So numbers.append 10. So the first list is updated. So now we have a new item in our first list. Then let's print the second list. Take a look. We don't have the number 10 here because these are two independent lists. So these are all the operations that we can perform on lists. We can add new items to a list. We can remove existing items. We can check for the existence of an item. We can sort our lists and copy them. Now here's the exercise for this tutorial. I want you to write the program to remove the duplicates in a list. Again, this is a fantastic exercise, so spend a few minutes on this and then come back, continue watching. All right, let's say we have a list of numbers with a bunch of duplicates. So 2, 2, 4, 6, 3, 4, 6, 1. We want to remove the duplicates. So we need to define another list. Let's call that Unix. Initially, we set it to an empty list. Then we need to iterate over our first list, get each item, and if we don't have that number in this Unix list, then we'll add it to the second list. As simple as that. So for number in numbers, now we need to check to see if we have this number in the second list. So we use the in operator. If number not in Unix, so note that here we are using the not operator. So if we don't have this number in this Unix list, then we'll need to add it. So unix.append number. That's all we have to do. So let's go ahead and print the Unix list. There you go. So we have 2, 4, 6, 3, and 1. The duplicates are removed. In this tutorial, I'm going to talk to you guys about another important structure in Python called tuple. Tuples are similar to lists, so we can use them to store a list of items. But unlike lists, we cannot modify them. We cannot add new items. We cannot remove existing items. We say tuples are immutable. We cannot mutate or change them. Let me show you. So I'm going to start by defining a list of numbers, 1, 2, 3. So we use square brackets to define lists and parentheses to define tuples. So if we change this to parentheses, 1, 2, 3, now we have a tuple. So if we type numbers dot, look here, we don't have the append or insert methods. So we cannot add new items to this tuple. We also don't have remove, clear, and pop. We cannot remove any of these items here. We only have two methods, count and index. We use count to count the number of occurrences of an item, and index to find the index of the first occurrence of an item. So we can only get information about a tuple. We cannot change it. And by the way, these other methods that you see here, they start with 2 underscores. We refer to these as magic methods. They're more of an advanced topic, so they go beyond the scope of this tutorial. If you're interested to learn about them, you can get my Python course. I've covered them in detail. So similar to lists, we can access individual items using square brackets. So we can get the first item like this and then print it on the terminal. There you go. The first item is 1. But if we try to change the first item, we'll get an error. So numbers of 0, we set it to 10 and run our program. There you go. We get this type error because the tuple object does not support item assignment. So we cannot mutate or change tuples. They are immutable. Now, practically speaking, most of the time you'll be using lists, but tuples are also useful. If you want to create a list of items and you want to make sure that nowhere in your program you accidentally modify that list, then it's better to use a tuple. In this tutorial, I'm going to show you a powerful feature we have in Python called unpacking. So let's define a tuple called coordinates. And here we pass 3 values, 1, 2, 3. So imagine these are the coordinates for X, Y, and Z. Now let's say we want to get these values and use them in a few expressions, in a few complex expressions in our program. Maybe we want to include them as part of a large complex formula. So to get them, we'll have to write code like this. Coordinates of 0. Then let's say we want to multiply this by coordinates of 1 and then multiply it by coordinates of 2. Our code is getting a little bit too long. This is just a very simple example. But let's say we want to use these values in quite a few places in our program. So a better approach is to get these values and store them in separate variables. Like we can get coordinates of 0 and store it in X. Then we get coordinates of 1 and store it in Y. And similarly, we get coordinates of 2 and then store it in Z. Now, instead of repeating coordinates of 2 or coordinates of 0 multiple times, we can simply work with these variables, X times Y times Z. That is better, right? So nothing new so far. But in Python, we have a powerful feature called unpacking. And with that, we can achieve the same result with far less code. So we can define our variables X, Y, and Z and set them to our tuple. What we have on line 6 is exactly identical to what we have on lines 2 to 4. So this is a shorthand to achieve the same result. So let me delete this and explain how this code works. When Python interpreter sees this statement, it will get the first item in this tuple and assign it to this variable. Then it will get the second item in this tuple and assign it to the second variable. And similarly, it will get the third item in this tuple and assign it to the third variable we have here. So we are unpacking this tuple into 3 variables. Now, if we print X, you can see X is 1. Similarly, Y is 2. There you go. So this is unpacking. And by the way, this is not limited to tuples. We can use this feature with lists as well. So if I change parentheses to square brackets, now coordinates is a list. So we can unpack this list into 3 variables. Now, run our program, we can see Y is 2. In this tutorial, I'm going to talk to you guys about dictionaries in Python. We use dictionaries in situations where we want to store information that come as key value pairs. Here's an example. Think of a customer. A customer has a bunch of attributes like name, email, phone number, address, and so on. Now, each of these attributes has a value. For example, the name can be John Smith. The email can be john@gmail.com. The phone can be whatever. So what we have here is a bunch of key value pairs. So in this example, our keys are name, email, and phone, and each key is associated with a value. So this is where we use a dictionary. With a dictionary, we can store a bunch of key value pairs. So let me show you how to define a dictionary in Python. Back to our program, I'm going to define a variable, customer, and here we set it to curly braces. With these curly braces, we can define a dictionary. In this example, we have an empty dictionary that doesn't have any key value pairs. Now we can add one or more key value pairs in between the braces. So let's add a key value pair here. I'm going to set the key to name and the value to John Smith. Then we add a comma to add another key value pair. So let's set age to 30. Let's add another key value pair is underline verified. And we set this to a Boolean. Now what matters here is that these keys should be unique. So if I add another key value pair here, let's set age to 40. Now look, PyCharm has highlighted the age key because we have duplicated that, and that's not allowed. So each key should be unique in a dictionary, just like the dictionaries we have in the real world. In a real dictionary, we have a bunch of words and their definition. Each word is listed only once in a dictionary. We don't have the word book twice. So let's delete this second duplicate key value pair. So the keys should be unique. And in this example, I'm using strings, but they can also be numbers. We're going to look at that later. But the value can be anything. It can be a string, a number, a Boolean, a list, literally anything. Now we can access each item in this dictionary using square brackets. So we type customer, square bracket, and then specify a key, like name. And this will return the value associated with the name key. Let's print it on the terminal. Have a look. There you go. So the name is John Smith. Now, what if we pass a key that doesn't exist? Let's say birth date. Run the program. We get a key error because we don't have a key called birth date. Also, if you spell name with, let's say, a capital N, we get the same error because we don't have a key with the exact same sequence of characters in this dictionary. Now, to get around this, we can use the get method. Let me show you. So instead of using the square brackets, we call the get method and specify our key. Now, if we use a key that doesn't exist here, it doesn't yell at us. For example, if we pass birth date, it simply returns the none value. Earlier, I told you that none is an object that represents the absence of a value. So instead of getting a key error, we get none. Now we can also optionally supply a default value. For example, if this dictionary doesn't have this key, we can supply a default value. Let's say January 1st, 1980. Let's run the program. Now, instead of getting none, we get this default value. So this is how we can access the value associated with a key in a dictionary. We can also update these values. For example, before a print statement, we can write code like this: customer of name. Let's update the name to Jack Smith. Now, this little warning here is telling us that we could simply put Jack Smith here instead of defining it once and then update it. Don't worry about that. It doesn't really matter. Now with this line, if we print the name of this customer, we should see Jack Smith. Let me show you. So I'm going to use the square bracket notation again. Let's print the name of the customer. You can see that is updated here. We can also add a new key here. Let's set the birth date to some value like January 1st, 1980. And then we can print it here. So as you see, we can easily add new key value pairs to a dictionary. So this is the basics of using dictionaries in Python. They're extremely important and they have a lot of applications in the real world. Okay, here's an exercise for you. So here we have this program that asks our phone number. Let's type 1, 2, 3, 4. We type it in digits, and then this will translate it to words. Take a look. Enter. It prints 1, 2, 3, 4. That's a pretty cool program. So go ahead and spend a few minutes on this exercise. It's pretty easy. I'll see you next. All right, so first we need to get the user's phone number. We call the input function with the label phone. We get the result and store it in this variable. Now let's say the user enters 1, 2, 3, 4. So we need to loop through this string, get each character, and translate it to a word. So what we need to implement this scenario is a dictionary, because a dictionary is a structure that allows us to map a key to a value. So we can have a dictionary with keys like 1, 2, 3, 4, and we map each of these keys to a word. So we can map the digit 1 to the word 1. We can map 2 to TWO. You got the point. So let's define a dictionary. We can call it digits underline mapping. Now in this dictionary, I'm going to add a few key value pairs. 1, we map it to 1, 2 to 2, 3 to 3, and finally 4 to 4. Now technically we should add all the digits from 0 to 9, but I don't want to waste your time typing repetitive things here. You got the point. So let's move on. Now we need to loop through the phone string. So for character in phone, we get each character and then use it to access a key value pair in our dictionary. So digits underline mapping, we can use square brackets or call the get method. I would prefer to use the get method. So in case the user enters some character that is not part of our dictionary, our program is not going to yell at them. So we call the get method and pass this character as the key. And if we don't have this key, we can supply a default value like an exclamation mark. So with this, we'll get a word. Now we need to add this word to an output string. So we can define an output string. Initially, we set it to an empty string. In each iteration, we get this and add it to our output string. So we type output plus equals this. And we should also add a space at the end. So the words are not close to each other. Okay, that's all we have to do. Now, finally, let's print this output, run our program. So I'm going to type 1, 3, 4, 5. Let's see what we get. We get 1, 3, 4 with an exclamation mark. In this tutorial, I'm going to show you something really cool that you can do with dictionaries. So here we have this program. We can type a message like good morning, followed by a smiley face. When we press enter, we get this beautiful smiley face. Or we can type I am sad with a sad smiley face, and it gets translated to this beautiful emoji. So this is another application of using dictionaries. We have a dictionary that maps these characters into smiley faces. So let's go ahead and build this program together. We start by calling the input function. Here we pass a greater than symbol as an indicator for the user to type a message. We get that message, store it here. As you know, that is a string. Now we need to split the string by a space. So if the user types good morning with a smiley face, we want to break this down into 3 words: good, morning, and smiley face. To do that, we can call the split method. So we call message.split and pass a string with 1 space as the separator. What this method does is basically it goes through the string, and anywhere it finds this character, in this case a space, it uses that as a boundary to separate this string into multiple words. And then it will return a list. Let me show you. So let's store that here, words, and then print it on the terminal. Let's go ahead and run our program. So if we type good morning, sunshine, enter, we get a list with 3 items. Each item is a string. Okay. Now, back to our program, we need to define a dictionary for mapping special characters like these 2 into a smiley face. So we can call that emojis, set it to curly braces. Here we add a key value pair, a smiley face, and we map that to a string. In the string, we want to add an emoji. If you're on a Mac keyboard, you can press Control, Command, and space, and this should bring up this emoji box. If you're on Windows, honestly, I really don't know how you can do this, but there must be applications that do this for you. So let's go ahead and pick this happy smiley face. Good. Now let's add another key value pair for a sad face. We map this to this face here. Good. So we have a list of words. Now we need to loop through this list, get each word, and potentially map it to an emoji. So we can write a for loop for word in words. Now we want to go to our dictionary and see if you have an item with this word as the key. If you have an item with that key, then we'll get its value. Otherwise, we want to use the same word. So if the user types good morning, we don't want to translate those words. We just want to return those. So that is the case where we use the get method to supply a default value. So we want to get an item with the key word. And if we don't have an item with that key, we simply use that word as the default value. Now, similar to the exercise that we did in the last tutorial, we need an output variable. So let's define that here, output set it to an empty string. Now back to line 9, we get the return value of the get method and add it to our output variable. So output plus equals whatever we get from the get method. And finally, we need to append a space at the end. That's it. We're done. So let's print the output and run our program. I'm going to type good morning, sunshine, with a smiley face. We get that. Beautiful. Let's try a sad face as well. I am sad. Too bad. Beautiful. So as you can see, dictionaries have a lot of use cases in real applications. Here's the solution from the last tutorial where we created an emoji converter. Now, so far we've been writing all our code right here in app.py, but as our programs grow, we need a better way to organize our code. We need to break up our code into smaller, more manageable, and more maintainable chunks, which we call functions. So a function is a container for a few lines of code that perform a specific task. For example, you have learned about a few of the built-in functions in Python like print and input. Each of these functions have a purpose. They know how to perform a specific task. So when building large, complex programs, we should break up our code into smaller, reusable chunks, which we call functions, to better organize our code. And that's what I'm going to show you in this tutorial. So let's write a simple program for printing a greeting message. So we're going to do a print, hi there, and let's add another message, welcome aboard. So here we have a simple program with only 2 lines of code. Now let's say these 2 lines, potentially we're going to need them in other programs. So we can put them in a function that we can reuse. Let me show you how to do that. So we start typing out def, that is a reserved keyword in Python, and it's short for define. When Python interpreter sees this, it knows that we're defining a function. Next, we need to give our function a name. Let's say greet underline user. So all the best practices you learn about naming your variables also apply here, which means you should name your functions with lowercase characters. If there are multiple words, you need to separate them using an underscore. And you should always use meaningful and descriptive names for your functions. So here we're defining a function called greet user. After that, we need to add parentheses followed by a colon. Now, you know that whenever we add a colon at the end of a line, we're telling Python that we're defining a block of code. So when we press enter, the next line is indented. Now, any code that we write here will belong to this function. So I'm going to move these 2 lines, these 2 print statements inside of our function. We can simply press tab to indent them. Beautiful. Also, let's remove this extra line break. That is better. So these 2 lines now are part of our greet user function. So whenever we call this function, these 2 lines will be executed. Okay. Now let's remove indentation. So here we are outside of our function. Let's do a print statement and print start. After that, let's call our function. So greet user. And finally, let's do another print statement and print finish. Now we have this little warning here, this underline. If you hover your mouse over this line, this tooltip is telling you that we should add 2 blank lines after function definition. This is coming from PEP 8, which is a document that defines the best practices for formatting our code. We'll look at that in the future. So for now, to make PyCharm happy, let's add an extra line break after this function. So whenever we define a function, we need to add 2 line breaks after. Okay. So now let's run our program and see what happens. All right, so we get 4 messages on the terminal. First, we get the start message. Then we get the messages coming from our greet function. So hi there and welcome aboard. And finally, we see the finish message. So let me explain the flow of our program. When Python runs this code, it doesn't actually print these 2 messages on the terminal because these lines of code are inside of this function. So they will only get executed if we call this function. If we don't call this function, these lines will not get executed, okay? So the execution of our program actually starts here. The first message that we see on the terminal is the start message. After that, Python sees that we're calling the greet function, so it will jump over here and then execute these two lines. Then it will jump outside of this function and continue the normal execution of our program, so it will print the finished message on the terminal. So this is how functions work. Also note that the order of this code matters. So here we're calling the greet function after we have defined it. If you try to call it before you define it, you will see an error. For example, if we call the greet user function right here, see, we immediately get this red underline, which says unresolved reference greet user, which basically means Python doesn't know what is this greet user. It's not defined anywhere. So we always define our functions first and then call them. Here's the function we created in the last tutorial. Now I got a question for you. What is the difference between calling this function and the print function of Python? The difference is that the print function takes some information, in this case, the message that we want to print, but our greet function doesn't take any information. Wouldn't that be nicer if you could pass the name of the user here, and then instead of saying, hi there, we could print the name of the user? So in this tutorial, I'm going to show you how to pass information to your functions. And that is pretty easy. So back to the definition of our greet user function. Inside of this parenthesis, we can add parameters. These parameters are placeholders for receiving information. For example, we can add a name parameter, and with this, we can pass the name of the user when calling this function. So let's pass John here. Now, when we call this function and pass this value, this name parameter will be set to John. So it will act like a local variable that we define inside of this function. Just imagine we didn't have this parameter, and instead we had a variable like name that was set to John. Now here, we could simply print the name of this user. So we could use a formatted string and print the value of the name variable, right? Now, we don't really have this local variable defined in this function. We have a parameter. It's exactly the same thing. So with these parameters, we can receive information in our functions. Now let's go ahead and run this program. So take a look. We get, hi John, welcome aboard. We can take this to the next level. Now we can call this function one more time. So greet user, and this time supply a different name. Let's say Mary. So we are reusing our greet function and passing it a different value. Imagine if we didn't have this function, we would have to repeat this line twice. Once for hi John and another time for hi Mary. So this is the benefit of defining functions. We can take a few lines of code that have a specific purpose and put them inside of a function. So now let's run our program one more time. There you go. So we get hi John, welcome aboard. Then we get hi Mary, welcome aboard. Now note that when a function has a parameter, we are obligated to pass a value for that parameter. So if we remove John from here and run our program, we get this type error, greet user missing one required positional argument. Argument in programming is the value that we supply to a function. So back to this example, Mary in this case is an argument that we pass to the name parameter. A lot of programmers don't know the difference between parameters and arguments and think they're the same, but they are not. Parameters are the holes or placeholders that we define in our function for receiving information. Arguments are the actual pieces of information that we supply to these functions. Okay, so let's bring back this John string. Okay, now we can also define multiple parameters. For example, let's rename this parameter to first name. As I told you before, you can right click here, go to refactor, and then rename, or preferably you can use a shortcut. So the shortcut for this on Mac is Shift and F6. And this brings up the rename dialog box. Here we can change this to first underline name. Now we can add a second parameter, so comma, followed by last underline name. So back to our formatted string, let's also print the last name. Beautiful. So here when calling these functions, then we can supply another argument. So John Smith, and let's delete this line. We don't really need it anymore. Run our program. Take a look. Hi, John Smith. So in the last tutorial, you learned that whenever we define parameters for our functions, we should always supply values. Otherwise, we'll get an error. Let's look at that error one more time. So I'm going to delete the second argument and only pass John. Run our program. We get this message. Greet user missing one required positional argument. So these arguments that we have here, like John and Smith, we refer to these as positional arguments, which means their position or order matters. In other words, the first argument we add here is the value for the first parameter, and the second argument is the value for the second parameter. So if we change their position or order, we'll get different result. Let's take a look. Let's pass Smith first and then John. Okay. Delete. That's good. Let's go with this. So instead of getting hi John Smith, we get hi Smith John. So that is the reason we refer to these arguments as positional arguments. Their position or order matters. But in Python, we also have keyword arguments, and with those, the position doesn't matter. Let me show you how they work. So let's say here we want to pass John as the value for the first name parameter. We can simply specify that here. So first name equals John. Now what we have here is a keyword argument. So this combination of having the parameter name followed by its value is what we call a keyword argument. And with these keyword arguments, the position doesn't really matter. So here we're supplying John as an argument for the first parameter. Now, similarly, we can use a keyword argument for Smith. Let me show you. So last name equals Smith. So now we have two keyword arguments. So with these keyword arguments, we don't have to worry about the order of the parameters. That doesn't mean we should always use keyword arguments. Not really. Most of the time, we use positional arguments, but in certain situations, these keyword arguments help us improve the readability of our code. So on line 7, it's quite clear that we're supplying Smith as the last name and John as the first name. Now, in this particular example, even if we didn't have the keyword arguments, just passing two positional arguments like John and Smith would be sufficient because it's easy to guess what is the purpose of these arguments. But sometimes you're dealing with functions and you're passing numerical values to them. In those situations, it may not be quite clear what these values represent. Let me show you an example. Let's say we have a function for calculating the total cost of an order. So we can call that calculate underlying cost. So when calling this function, we need to supply three pieces of information. One is the total cost of all the order items, let's say $50. The other is the shipping cost, let's say $5. And the last piece is a discount, let's say 0.1. Someone reading this code may not be sure what these three values represent. In this case, we can improve the readability of this code by using keyword arguments. So we can prefix each value with the name of the parameter they target. For example, we can set total to 50 and then shipping to 5 and discount to 0.1. Now, if we give this code to someone else, they can immediately tell what these values represent. So that is the power of keyword arguments. So here's what I want you to take away. For the most part, use positional arguments, but if you're dealing with functions that take numerical values, see if you can improve the readability of your code by using keyword arguments. You simply prefix the arguments that you pass with the name of their parameters, and this will increase the readability of your code. Now, there is one more thing you need to know about keyword arguments. These keyword arguments should always come after positional arguments. Let me show you what I mean. So, back to our simple greet user function. Let's use a keyword argument for the first name. So, let's set first name to John and see what happens. Look, we immediately get this error. Take a look. Positional argument after keyword argument. So when calling this function, we're supplying one keyword argument and one positional argument. And Python doesn't like this. So if you're mixing positional and keyword arguments, you should always use the positional arguments first and then the keyword arguments. In other words, let's remove this keyword argument here. So John is now a positional argument, is targeting the first parameter, right? Now, after this positional argument, we can supply any number of keyword arguments. So if we set last name to Smith, look, Python doesn't have any problem with this because we're adding a keyword argument after a positional argument. So let's quickly recap. For the most part, use positional arguments. If you're dealing with functions that take multiple numerical values and it's not quite clear what those values represent, use keyword arguments to improve the readability of your code. And finally, if you're passing both positional and keyword arguments, use the keyword arguments after the positional arguments. So far, you have learned how to create functions and send them information using their parameters. In this tutorial, I'm going to show you how to create functions that return values. This is particularly useful if you're doing some kind of calculation in your function and you want to return the result to whoever is using your function. Let me show you. So let's start by defining a function called square. This function simply calculates the square of a number. So we need to add one parameter here, that is our number. Now here we want to calculate number times number, that is the square of a number. Now, to return this number outside of this function, we simply use the return statement. So return. Now, our square function is very simple. It only has one line of code. But in a real program, you might have a function that has 10 lines of code to calculate something. So this return statement is very valuable. With that, we can return values to the callers of our function. So with this, when we call the square function, let's say we give it 3, now this function returns a value, just like the input function of Python. This input function waits for the user to type something and press enter, and then it will return the user's input as a string. So we can get it and store it in a variable like this, right? We have the same story with our square function. So our square function returns a value. We can simply get it and store it in a variable. Let's call that result. Now we can print result on the terminal. There you go. So result is 9. We could also pass this function call directly inside of the print function without defining a separate variable. Sometimes this is useful for writing shorter code. So in this case, we don't really need this result variable. We simply want to print the square of 3. So we could simply pass this function call right here as an argument for the print function. So let's delete this variable. Now our code is shorter. So with this, we're calling the square function. This returns a value, and we'll pass that value as an argument to the print function. Okay? When we run this program, we get the exact same result. There you go. Now, what happens if we don't use a return statement in our function? So in the last example, we simply used a print statement. Let's temporarily remove this return statement and print the result on the terminal like this. So let's run our program one more time and see what we get. We get two things on the terminal, the number 9 and none. What is happening here? Well, when Python interpreter executes this code, first it will call the square function. So the control moves to the square function. Here we calculate the square of this given number and then print it on the terminal. That is the reason we see 9 right here. Now, by default, all functions return the value none. So if we don't have a return statement here, by default, Python returns none. None is an object that represents the absence of a value. It's like nothing, or null in C, C++, Java, and JavaScript. So in this example, we didn't have a return statement, and by default, Python returned none from this function. So after this square function is executed, the value none is returned and passed as an argument to the print function. That is the reason we see none on the second line. So here are the two things you need to take away from this tutorial. By default, all functions in Python return none. You can change that. So if you have a function that calculates something, you can return the result using the return statement. Here's the code for our emoji converter program that we wrote earlier. If you missed that tutorial, make sure to go back and watch it. As I told you before, there is a table of content right below this video in the description. So you can simply click on the emoji converter tutorial to watch it. Now, your exercise is to reorganize this code using a function. So I want you to extract a function in this code. Because this algorithm for converting these smiley faces into emojis is something that we probably want to use in a lot of different applications. We can use it in a chat application, in an email application, and so on. We don't want to write all this code every time. We want to convert these characters into smiley faces. So out of all these lines of code that we have, from line 1 to line 10, the lines 2 to 9 belong to our algorithm. All these lines together implement this feature. So you should put these lines in a separate function. Now, why don't we have the input in that function? Because the input can come in different forms. Currently, we're using the input function to receive the input from the terminal, but in other applications, we might receive the input from a graphical user interface. So the input can come in different forms. We don't want to put that in our function because this line will not be reusable. We want to give our function the actual message as a string. We don't care how we got that message. In one program, we might get it from the terminal. In another program, we might get it from a graphical user interface. So that is the reason this line of code should not be in that function. By the same token, you shouldn't include the last line in that function because what we do with the output is different from one program to another. In this program, we're printing the output. In another program, we might send that output as an email or as a response in a chat application. So as a general rule of thumb, your function should not worry about receiving input and printing it. These lines of code should not belong to your functions. So go ahead and reorganize this code by extracting a function. All right, on the top, first we need to define our function. So we type def, give our function a name like emoji underline converter. So the name of this function clearly tells me what it does. Each function should be responsible for one and only one task, and that task should be clearly explained in the name of the function. Okay, so our emoji converter function should take a parameter. We call that message. That is a string, right? Colon. Now we need to move the lines 5 all the way to the end of our for block into that function. So let's select all these lines. We can cut them from here by pressing Command and X on Mac or Control and X on Windows. Then we paste them here. As you can see, these lines are automatically indented, so they are part of the emoji converter function. If this didn't happen on your computer, make sure to select these lines and use the tab to indent them. All right, so here's our emoji converter function. Beautiful. Now, after that, In the main flow of our program, first we get the input from the user, we store it in this variable message, and then we call emoji converter and pass this message. This function should return a value. That is what we calculate at the end of this function. So right after this for block, we need to add a return statement, return output. Now that our function returns a value, we can get it and store it in a separate variable. Let's call that result. And then we can simply print that here, or we can make this code shorter. We don't really need this variable here. So we can simply call the emoji converter and print the result like this. Now here we have an underline because, as I told you before, we need 2 blank lines after our function definitions. So currently we have only 1 blank line. We need to add another blank line. Good. Let's go ahead and run this program to make sure everything works as before. So I'm going to type a message like good morning with a smiley face. Good. Let's run it one more time. I'm sad. Too bad. Okay, beautiful. So here's the final result. We defined this function called emoji converter. This function takes a parameter called message and finally returns the output.